Am I audible?
Yes, Prashant, you are.
So thanks for the confirmation. So today cover the concepts of the nine to virtual. I have collected some questions. We'll discuss and we'll try to know, cover all the topics. And Poisson distribution is there, right? In the week 11, Poisson distribution and hypergeometry. These two topics are there, or anyone can confirm me for this? Hello, am I audible to all of you, right?
Yes, sir. You are audible, sir.
Yes, yes, audible.
Yeah, so I was asking, Poisson and hypergeometric is there in week 11. Okay, how many of you have covered the all the lecture video of week 12 till week 12? No one, huh? Okay, so I'm going to share my screen. I have collected some questions related to concepts of week 9 to week 12. Okay, so we'll discuss each and everything so that you can get the idea how you can solve the questions related to that topics. Okay. So in week 9, if you have remembered, we have covered random variables, probability mass function, and all things, right? Discrete random variable, continuous random variable. Okay, am I right? Okay. So in week 9, we have covered random variable, discrete random variable, what is continuous random variable, no? Probability mass function, probability density function, and all things. So actually, probability density function, I think it's from week 12. But yeah, in
सर
week.
आपकी सर हेलो.
Hello.
हाँ सर, आपकी वॉइस सर ब्रेक हो रही है सर.
Is it for everyone or now is it okay? Hello. Hello. Anyone can confirm me? Is it
Yes, yes.
सर अब
clear for
सर
everyone? Okay. So let's start. Anyone of you can tell me what is the meaning of random variable? Anyone? What do you understand by the random variable? Okay. So basically, see, uh, random variable is nothing but, see, suppose I'm doing any experiment, right? Any probability experiment is going to perform. Let's say rolling of a die, correct? Rolling of two die, you can say, or rolling a die twice, anything. So it might be like we are not interested in all the outcomes. Rather than I'm interested in what is the outcomes of sum of on both die, right? So I can define my a random variable x, which will take value, right? suppose I'm defining my random variable x, which is nothing but the I can say like sum of numbers on both die, correct? So I can define that random variable. So now we are interested what random variable can take possible values. Okay, so basically it's nothing but you can say it's a real valued function defined on your sample space, right? So when you roll a die twice, your sample space will be 1 1 1 2 up to 1 6. Similarly 6 1 6 2 6 6. I mean you will get total 36 outcome. Okay, that will be my sample space, but random variable will take some of the outcomes from your sample space, right? So you can expect random variable is nothing but the outcome of a random experiment. What is the random experiment? As you know, outcome is not predictable with certainty, right? Suppose I'm going to toss a coin. I know outcome will be either head or tail, but I can't predict whether head will come or tail will come, like that, right? Suppose I roll a die, then I know outcome will be either 1 to 6. Okay, but suppose I can't predict whether one will come, two will come, or anything any another number, right? So random variable is, you can say, suppose I'm define random variable x, which represents the even number after rolling a die. So values of x will be 2, 4, 6, like that. Okay, so far so good. So first question is based on the random variable. So here it says that range of a random variable is set of all possible values that x can take. So I'm going to say let a random, see meaning of what is the range of random variable is nothing but set of all possible values that x will take. Now I'm going to define a random variable y is defined as the number of tosses until first head comes, right, on tossing a coin. So tell me what should be the range of y? What values y should take? Y is nothing but the number of tosses until the first head comes. Anybody?
Prashant, I think it's D, option D.
Option
D.
D.
Huh.
Okay. Anybody else? Yeah, please. I mean, respond like this. It's for you. It's not. I can quickly revise the topics. There is no need to discuss the questions and all things. It's not for me, right? So it's for you. If you tell me some question, if it's wrong, we'll discuss why it's wrong, why it's like that. The,
Prashant, the reason why I think it's option D is
Mhm.
because imagine you get the first head in the first toss itself.
Correct.
Oh, okay.
Okay.
Number of tosses until the first head is 0. Okay.
Oh, see, you are going to consider like this, right?
Huh.
Right.
Tail, huh? Correct, correct, correct.
So this is not thing. It is asking about number of tosses, right? So I'm saying option C is correct.
Oh, okay.
Why? I'm see whether you will get a head or not. It's not about the number of head. It's not about like you have to toss the coin till you get first head, right?
Correct.
It's asking about number of tosses. Whether see for getting a tail or head anything, I need to toss a coin at least one time.
Mm-hmm.
It's see you are getting this. I'm going to emphasize this word number of tosses required. So it's one toss required to get first hit. It may be it will tail or head. It's not about whether head is not head is at that point or not, right?
Mm-hmm.
So option C is the correct. I need at least one tosses,
Mm-hmm.
then second tosses, then third tosses.
Okay. So the first T should actually be an H, right? H, T, H, T, T, H.
Yeah, yeah, correct, correct. It should
Mm-hmm.
be HTH.
Okay, okay,
Then
got it.
I must need yeah, thanks for this. I must need at least one toss, correct?
Yes.
So for everyone it's clear what is the random
Yes,
variable and how it can take values and all things. It can take, okay. Okay. So anybody can tell me what is the meaning of discrete random variable and continuous random variable? So yeah, discrete means something which I can count, right? Which is something countable. And what is the meaning of continuous? Continuous means which I cannot count. Suppose I have any continuous data, I cannot count that continuous data. I have to measure that thing, right? There is measurement. And discrete random variable, suppose I'm saying, let's say number of pen, correct? So it's one number of pen in a box. So it may be one pen, two pen, three pen, four pen, and so on. So if you see, it is countable things, right? First thing. And second thing, it cannot take any values between 1 and 2. In between, it cannot take any values. And what is the continuous? Continuous is measurement is involved. We cannot count the continuous data. We have to measure. And it can take any value between an interval. Let's say I'm saying, you can say weight of a person, correct? So weight of a person in a, suppose there is a group of person age, I mean, whose age are above 40. So it may be weight can be like 60 to 80. I'm going to take. So see, first of all, weight is something we have to count or we have to measure. Weight we cannot count, right? Weight is something which we cannot count. Weight is something we have to measure in kilogram, right? We have to measure weight in kilogram. We have to measure the height. We cannot count the weight and nothing. And suppose and I'm going to measure the weight of a person. So it can take any value between this these two interval. Okay, according to that specific interval. It is clear. So that is something where measurement is involved, continuous random variable, and if we can count, that is the discrete. Okay. So second question is based on that. Question is a machine measures length of synthetic fabrics and associated imperfections in the fabric. I'm saying X be the error in the measurement of length and Y be the number of imperfections per 10 meters. So which option should be correct? There more than one option can be correct. So accordingly, which should be the discrete random variable and which should be the continuous variable?
Um, so
X is a continuous variable.
correct.
Okay.
And Y is a discrete variable.
Okay. X is Y continuous. Y X is continuous.
No. X is continuous. Y is not continuous.
Yes.
Okay. Okay. So Y is discrete.
Because it says number of imperfections.
Correct. And I can count, yeah, one imperfection, two imperfection kind of things, right? But X is the something I have to measure that thing. I have to measure the length, right? It's suppose 10 meter, 9 meter, and also it can be 8.72 meters kind of things, right? So here X is something what? X is I have to measure the length. I cannot count the length. I have to measure. I have to measure the weight. I have to measure the height of a person. Suppose I'm saying speed of a vehicle. So speed is something we have to measure. We have to measure. I mean measurement is involved there, right? So it's clear about continuous and discrete random variable.
Yes.
Okay.
Yes.
Yes.
Yeah, another question is again based on the discrete random variable so that you can get more idea on this. So question is which of the following is our discrete random variables? So first one is length of the phone call. So whether it is discrete or continuous?
Discrete.
Continuous.
Continuous.
Why discrete?
Mm, because number should be 10. Oh, okay. Continuous.
Yeah, it's a
Hmm.
continuous. It's length of a
Hmm.
call, right? It can be suppose I'm going to take maximum you can talk on around 1 hour. So suppose I'm saying it's a 0 to 60, 0 minutes to 60 minutes. Okay. So it's a length of a phone call. First of all, you can measure in time, right? Second, minute, and all things. Second thing, it can take any value from 0 to 60 minutes. Okay. What about option number B? So this is not a discrete random variable. What about option B?
Discrete.
Discrete.
Discrete, correct? I can count number of customers, right? Yeah, 3 customers, 4 customer and all things, right? What about option number C?
Continuous.
That
Continuous.
is continuous.
Because it's the amount of milk, so I can measure amount of milk, right? 1 liter
Hmm.
produced, 2 liter kind of things, right? And what about option D?
It's discrete because number of
Discrete.
answers.
Correct, correct. I can count, right?
Yeah.
And what about option E?
Continuous.
Continuous. It's a travel
Hmm.
time from your office to the, sorry, from your home to the office, right? Think this is the travel time, so I have to measure, right? So this is not a discrete. So B and D was the correct option which we have discussed. Okay, it's clear about continuous and discrete. Next
Yes.
question is based on the PMF. You know what is the PMF? PMF is C. What is the, yeah, suppose my random variable X is going to take some values, right? X1, X2, I'm taking as Xn. Okay. And I'm interested in probability associated to each values of X. Okay. I mean, I'm interested in probabilistic behavior of random variable X on each values of this, right? So suppose I'm interested, what is the probability when X is going to take X1? Suppose it is P of X1. For X2, it is P of X2 and so on. For Xn, it is P of Xn. So this is something, whole things is known as the PMF, probability mass function, right? Now, there is two important properties for being a PMF. First one is all the probabilities should be greater or equal to 0, correct? Second probability is, second property is sum of all the probabilities, means summation of P of X1 plus summation of Px2 plus summation of Pxn should be equal to 1. So these are the two important properties for being a PMF of a discrete random variable. Okay, it is clear?
Can you repeat that one, please?
Yeah, I'm saying what is the PMF? PMF means probability. This is full form for PMF is probability mass function. So it's nothing but basically, suppose I have X, right? X is my random variable and it is take it takes values X1, X2 and so on Xn. Okay. So I'm interested in probabilistic behavior at each values of X. Probabilistic behavior means what is the probability when X is going to take X1? Suppose it is P of X1. What is the probability when X is taking the value X2? Suppose it is Px2. What is the probability X is going to take value Xn? Suppose it is Pxn. So the whole things, values X is going to take and probability at each point of X, at each values of X. This whole things known as probability mass function. And there is two property for being a PMF. First one is all the probabilities should be greater or equal to 0. Okay. Second is summation of all the probabilities, sum of all the probabilities should be equal to 1. Okay, these are two important things about the probability mass function.
So it means that the x1, x2, xn is the sample space.
Sample space, yeah, you can say possible outcomes for my random variable.
Okay,
Okay,
which means sample space, right?
correct.
Okay.
Not
Right.
total sample space. See, sometimes suppose, okay, suppose I roll a die twice. Okay,
Hmm.
so what will the sample space? 36 outcomes.
Yes.
Okay, suppose I'm going to define my random variable X as even number on both die. Okay, so what will the random what values X will take? X will take 2 comma 2, 4 comma 4, 6 comma 6, correct?
Yes.
These three values X will take. I'm saying X is the uh, even number on both die, right? So
Hmm.
what will the probability of X is taking 2 comma 2, 4 comma 4, 6 comma 6? Accordingly we have to think, right? Now let's forget about rolling a die two times. Suppose I'm going, X is defined outcome of outcome of a die, okay, and I'm rolling only one time, right? So what will be the X? X will take value 1, 2, 3, 4, 5, 6,
Yes.
correct? What will be
Yes.
probabilities?
1 by 6, 1 by 6,
1 by 6, 1 by 6, 1 by 6, 1 by 6, 1 by 6, okay? So
Yes.
this whole things, if I'm going to represent, so this will known as the probability mass function for my X. Here you can say all the probabilities are greater or equal to 0,
Yes.
correct? And sum
Yes.
of all the probabilities should be equal to 1. If
Yeah.
you
If
add
the
1 by
sum
6
of
plus 1
all,
by 6,
if the sum of all probabilities are 1, then it defines the sample space, right? I'm just trying to understand that.
yeah, see, you have to consider all the possible values X should take accordingly the probabilities. If is sum of all the probabilities equal to 1, then it's a PMF for that random variable.
Okay. Okay.
Okay.
Got it.
Yeah. So next question is related to probability mass function. So here a random variable X is something which takes the value 1, 2, 3, 4, 5. Okay. And you have to find the probability of X equal to 5. Okay. So I think I'm going to give you 4 to 5 minutes. So you can solve and tell me uh, what is the correct option. Okay. Probability mass function, it said it is probability mass function. Okay. And what will be the probability of X equal to 5? So from the table, it is 3t by 2, correct? But we don't know about value of t. So how I can compute the value of t?
Now, 1 for 1 it is 0. So as
Yes.
per definition, it should be greater than 0 or greater
No,
than or
it can be
equal to
greater
0.
or equal to 0, right?
Equal to. Okay. Okay.
See, suppose I have probability, so probabilities can be 0 to 1, right?
Okay.
Probability can, yeah. So here we have to find the value of this unknown quantity, which is t. If I will know what is the value of t, then I can easily compute the probability of X equal to 5. Now here you have to apply the property of the
1.
probability mass function. Okay.
Yes. So summation should be 1, right?
Summation should be 1. I know the equation. Okay. So
Yeah.
I know summation should be equal to 1, right? So what is the summation of all probability? It's 0 plus t by 2 plus 4t square plus 3 times t divided by 2 should be equal to 1 according to my definition. Correct? Now what should be the next step? Next step nothing but, okay. So this is t. So this is t and 3t is 4t by 2, correct? Plus 4t square equal to 1. I can write down it's 4t square plus 2 times t plus t equal to 1, correct? So I can write down 4t square plus 3t minus 1 equal to 0. I can write down or not? Now this is this equation I can solve. I can write down 4t square plus 4t minus t minus 1, correct? So here it will be 40 I can take as common, so it will be t plus 1 and minus 1 I can take common. So t will be 1 by 4, correct?
Yes.
Now, so can you tell me which values I should take, whether t equal to minus 1 or t is equal to 1 by 4?
Equal to 1 by 4.
Because
Okay.
the probability should be greater than 0.
So if we will take value t as minus 1, then this probability will be in negative. Means probability cannot be negative, property will not satisfy. So we have to take value of t as 1 by 4. So probability of X equal to 5 is 3 times t by 2. So 3 by 2 into value of t is 1 by 4. So it will be 3 by 8. So that means option number C is correct. It's clear meaning of PMF and all things.
Yes.
Okay. Thanks.
Yes.
Okay, now come to the CDF. CDF is nothing but full form CDF is cumulative distribution function. So as you can see from the probability mass function, here I can easily find out the probability at a particular point, correct? From this probability mass function table, suppose I'm saying tell me value of probability x equal to 3, you can easily tell me it's a t by 2, correct? Right. Now I'm saying suppose I'm interested in what is the probability x is less or equal to 3. That means we have to, what we have to do? Suppose I'm saying tell me the probability of x is less or equal to 3. What we have to do?
Sum from 1, 2, and 3 and provide that.
Correct. So that means we are accumulating the probabilities from 1 to 3.
Yes.
Right? We are going to see rather than interested in only probability at a single point. Suppose I'm interested in till 3. That means we have to accumulate, we have to add, we have to combine all the probabilities till the 3, right? So that's its meaning of cumulative distribution function. We have to consider the probabilities at till that point. Okay, it is clear why CDF comes into the picture.
Yes.
So CDF of a random variable, I'm going to say is f of a, nothing but probability x is less or equal to a. That is the nothing but meaning of the CDF. Okay.
Yeah, sorry for interruption, Prashant. Can you please explain the CDF again?
Okay. So what is the what PMF tells us? Suppose I'm saying tell me the value. Sorry, probability when x is going to take value 3. Okay. So here I'm saying, so you can easily tell me the value probability value at x equal to 3 from the PMF, correct? Means rather than suppose here I'm interested in the probability at a single point, but suppose I'm interested in probability. Suppose I'm saying tell me probability what will be the probability x is less or equal to 3, correct?
Yes.
So that means I'm interested in the probability of random variable less than or equal to this particular point, this 3, correct? Or you can say greater or equal to something. That is another thing. We'll see that thing. So rather than interested in particular point, I'm saying I'm interested in the probabilities less or equal to this 3, correct? So for this, I have to accumulate all the probabilities when it is taking value 1, when it is taking value 2, when it is taking value 3. I mean, we have to accumulate all the probabilities when x is going to take the values less or equal to before that particular point. That means then, I mean, that's name cumulative distribution function.
So cumulative distributive function is only for discrete variable, right?
No, you can define for the continuous random variable also.
Also.
Yeah, we'll discuss that thing when
Okay.
continuous will come. Okay.
Okay.
So far it is clear we are interested in a probability less than or equal to particular point, right?
Yes, Prashant.
Okay. Yeah. So next question is based on the cumulative distribution function. So cumulative distribution function, there is a of the number of defective items in the shipment of every 10 items is given is. So now we have to find the probability that there are 3 defective items. So it is asking about probability of 3 defective items. Okay. Now, so it is asking about a particular point. So what we can do, can I found the PMF from the CDF?
Yes.
I can found. Okay. Let me give you a hint. Okay. Let me Okay. Suppose a PMF is given to us. I'm write down the PMF. I will tell you how we can compute the CDF. After that, you will get some idea. Okay. Suppose X is taking value 1, 2, 3, and 4. Okay. And probability for each xi, let's say for 1, it's 1 by 4. For 2, it's 1 by 2. Then it's 1 by 8. Then what's remaining? 4. I think it's 2 by 8. And 4 to 6 and 6 to 8. Okay. Sum of all the probability is equal to 1. Okay. Now, what is the CDF? So, CDF I can compute like. So, first, suppose I'm saying my A, I can define as A. So, suppose I'm saying A is less than 1. So, what will the probability when A will be less than 1? I mean, suppose this is the X. I mean, let's then make it X. What will the probability when my X will be less than 1? From this
0.
0, correct? Now, what about the probability of X greater or equal to 1 but less than 2? That means,
1 by 4.
yeah, we have to consider this only this probability 1 by,
Yeah, 1 by 4.
correct? Now, what will the probability when X is greater or equal to 2 but less than 3?
It will be 1 by 4 plus 1 by 2, which is 3 by
Correct, correct. It will be, I think, 3 by 4, right?
3 by 4.
Right?
Hmm.
What about the probability X will take greater or equal to 3 but less than 4? That means I have to accumulate all the probability this,
Until 3.
this, and this, right?
Yeah.
So it will be
7 by 8. Yeah, 7 by 8.
Correct? What about the probability when X will be less than or equal to 4? 1.
Prashant, it has to be greater than or equal to 4. Prashant?
Yeah.
Greater than or equal to 4.
Yeah, this is same, right?
Okay, okay.
Okay.
Okay,
So,
thank you.
yeah. So it will be 1 because for X is greater or equal to 4 means we have to accumulate all the probability from 1 to 4, right? 1 by 4 plus 1 by 2 plus 1 by 8 plus 1 by 8. Since this is the PMF, so total should be 1. Total should be 1, correct? So now this is the procedure for obtaining the PMF to CDF. Suppose I'm saying what is the procedure for obtaining the CDF to PMF? So this is the 0. Okay.
Just a minute.
Yes.
Just a minute. In the 3 less than or equal to x less than 4. So it means only 3, right? Which is 1 by 8.
Okay, why?
Because only.
Okay, see, I'm saying X is these things, right? Forget about less equal to sign. That means
So this means 3 is less than x, right?
3 is less than X.
Which means x can be 3.1 or 4 or 5. It cannot be 2 or 1, right?
Okay. Okay. Where you are making. Okay, so what about this thing?
Yeah, so this
Mhm.
means x is greater than or equal to 1 and less than 2. That's the meaning, right?
Yes.
So at that place, all probabilities less than 2 should be given.
Okay.
So can you please scroll up? I'm just
Yeah.
trying to see what is the
Okay.
value. Yeah, so it is 1 by 4. That is correct.
Correct. And what about this?
Here it means x is greater than or equal to 2 and less than 3.
Yes.
So in that case, we cannot add the probability of 1, right? Because x is supposed to be greater than 2.
Okay.
So
Okay,
assuming
just
that
Okay.
Assuming,
Yes.
assuming that the definition of the probability is like number of times single person enters the gate, 2 persons enter the gate, 3 persons enters the gate, 4 person enters the gate. The probability of 2 less than or equal to x less than 3 means at least 2 people come, but
Okay.
less than 3 come, right? In that
Mhm.
case, the probability we have clearly defined it as 1 by 2.
Okay. So you are saying it should be 1/2, not so it should be 3/4, right?
Yeah, that's my understanding. I'm just asking
Okay.
if my understanding is wrong.
No. See, you are taking this going to take. Okay. Anybody wants to tell him?
So this f of x is a CDF. So where we
Correct.
have to take a cumulative one. So as the function
Correct.
says, f of a equals to probability of x less than or equals to a. So we have to
By
consider all.
definition, yeah, by definition. I'm sorry, that is
Yeah,
my
now it is
mistake.
clear. Okay.
Understood.
Clear?
Thank you very much.
Because for f of a, we are going to consider these things, right? Means we have to accumulate the probabilities till a point.
Okay,
Clear? I think
it means now that it is not 2 less than or equal to x less than 3. It is x less than or less than 3, right?
x is
Uh, it is
no, no.
not like
See, okay. What is the meaning of this? We have to consider before 3 all the probability, right?
okay.
Okay. We have
Yes.
to consider the less probability when x is less than 1. So x is less than 1, that means 0. I'm saying more than 1 and less than 2, that means it's 1/4. Less than 3, it should be, I have to add all the probabilities, right? Less than 4, I have to add accordingly. Okay.
Okay.
I have to accumulate all the probability till that point.
Okay.
Clear? Okay.
Yes. Yes.
And you see, for more clarification, you can try this step function. Okay, you can try the graph, right? Whether x is taking 1, 2, 3, 4. Okay, for 1, what is the probability? For 2, what is the things? For 3, what is the thing? For 4, so you will get a step function, right? So the
Yes.
probabilities, the jump will be the probability at a particular point. Otherwise,
Got it.
it will show. Okay, try to make that step function graph, you will get a clear idea. Okay, so what I'm trying to say here now, tell me what is the, okay, suppose I have this thing, suppose I'm saying tell me the value of suppose what is x is going to take 1, 2, 3 and 4, right? I'm trying to make here CDF to PMF. So what will the probability of 1 by seeing this one?
1/4.
1/4.
Okay, what will the probability of x equal to 2?
Okay, so you have to subtract from 3/4.
Correct,
3/4 say
because
1/4.
in the CDF we are adding the things, right? For the PMF we have to subtract 3/4 by 2, 1/4. It will be 1/2, right? 2/4, correct? Which is same as this one, right? Now, what about probability at x equal to 3?
Yeah, it will be 7/8 minus 3/4.
Minus 3/4. That is 7/8 minus 6/8. That means 1 by
1/8.
8, right?
Ah,
And what about probability x equal to 4? This
1
minus
minus
this.
7/8.
So you got, if your CDF is given to you, so you can compute the PMF and accordingly probability. Okay. Now tell me what is the probability when of 3 defective items? Directly you can tell me from the this table.
0.09. It's 0.09.
0.09. How did you compute
1
probability
minus
at x equal to 3?
1 minus
So
0.91.
1 minus
91.
0.91. So I can say x is greater or equal to 3 minus probability 2 is less or equal to these things, right? Okay. So which is nothing but 0.09, which is same as we have discussed here. It is clear for everyone? CDF to PMF and all things? Or any doubt in this?
Prashant, just for clarity's sake,
Yes.
just quickly draw the PMF from this CDF. Now, I just want to know if I'm correct.
Okay, okay,
Yeah, just
okay,
so we get
okay,
our concepts clear. Yeah.
okay. Nice. Okay. We'll look. What is the value is actually going to take here? 0, 1, 2, and 3, right?
Yeah.
Correct. What will the value when x will take value 0? 0.41. At x equal to 0, it's 0.41, right? What about value probability for value 1? 0.78 minus 0.41.
Yeah. 37.
It,
0.37.
it will be 37. What about when x will take value 2?
It will be
0.91 minus 0.78, right?
Yeah,
So
correct.
it will be 0.13. No, not 13.
Yeah, 1.3.
0.13, yeah.
Uh-huh.
And 0.09.
Yeah,
Now
correct.
you can check whether this is PMF or not. So for this is PMF, since all the probabilities are greater or equal to 0, correct? And if you add 0.41, 0.37, 0.13, 0.09, it will add up to 1. Okay. From here, you can obtain this CDF also. Less than 0, it's a 0. Because I do not have any probabilities less than 0, right? 0 to 1, that means 0.41. 1 to 2 means 0.41 plus 0.37. Correct? 2 to 3
Correct.
means add up to all this probability and greater equal to 3. Okay. CDF is like that. Suppose this is x is taking value 0. So before this, it is 0. And there will be some step function. Suppose this is the probability 1. After that, suppose this is 3. It will take value 1.
So
Okay.
can we assume that given
Mhm.
a CDF function, whenever the
Mhm.
probability is 1, that is the final value?
Yeah.
Okay.
Okay. It is clear. CDF, PMF and all things, right? I think week 9 it's all about, right? Random variables, discrete or continuous random variables, PMF, CDF. Okay. Now we'll move to the concepts of related to week 10. So in
Excuse me,
week
sir.
10, yes, yes.
So this is only for discrete random variables or same for continuous?
For what? CDF?
Yes, PMF and
Yeah,
CDF.
yeah. Yes, see, what is the PMF? Is nothing about information about my random variable. Yeah, my random variable is going to take these values and probabilities are associated corresponding to all values is this and all things. Okay. So similarly, we'll see about the continuous random variable. For continuous random variable, name is changed. It's a PDF instead of PMF. CDF is same, but yeah, there is another procedure to compute the CDF for in case of continuous random variable. Okay.
Oh, okay.
So
Thank you.
yeah, yeah. In week 10, things is nothing but expectation of random variable. Okay. And variance of random variable, Bernoulli random variable, I think discrete uniform random variable. Okay. So anybody can tell me what is the expectation of random variable?
E of x
Nothing.
square minus E of x the whole square.
No, no. I'm asking what expectation of x.
Oh, okay. X into P of
Okay.
xi. Correct.
Correct. So that means nothing but expectation of x means it's you can say as a weighted average. So expectation of x is nothing but I can compute by adding all the values. I mean by multiplying xi into pxi and then add up all the values. That means suppose I have this PMF. Suppose I'm asking what is the expectation of this random variable x. That means 1 into 0 plus 2 into t plus 3 into t by 2 plus 4 into 4t square plus 5 into 3t by 2. That is nothing but the expected value of a random variable, expectation of random variable. Basically, any one of you can tell you what is the meaning of expectation, first of all.
What is the most likely outcome?
Okay. Anybody else? Okay,
What
can you
is
tell me
the
what?
most likely success of any guess?
Okay, can you tell me what average tells us? Mean of a data tells us.
Central
Suppose you have a
tendency.
large data set. What average tells us? It gives a basically central idea.
Yes.
Yeah.
I mean, in a single number. Okay, you have large data set. Suppose you have class of 40 students. I will say, yeah, average marks of that class is, let's say, 62. Then you got a central idea about the marks of that class, right? So expectation is the similar kind of thing. Suppose I have random variable. Suppose I need to summarize the random variable into one number. Okay. Suppose here, in case of PMF, I summarize I give the information about my random variable. I write down all the values. I write down the probability and all things. But I want to summarize my random variable in a single number, rather than describing the whole distribution and all things, right? So that when in that case, expectation comes into the picture. What is the meaning of expectation? Is nothing but summation of xi into pxi, which is sometimes we say it's a theoretical average or kind of things, right? So that is the meaning of expectation, right?
So
So now,
what do we
yeah,
gain by getting that? So when we are given
okay,
a
okay. Suppose I roll a die, correct? I roll a die. What is the expectation value of x? It will be, I think, 1 into 1 by 6 plus 2 into 1 by 6 plus 3 into 1 by 6 plus 4 into 1 by 6 plus 5 into 1 by 6 plus 6 into 1 by 6, right?
Yes,
X
yes.
into probabilities. It will be 1 by 6, 1 plus 2 plus so on 6. So it will be 6 plus into 6.
6 into 7 by 2, which is 7 by 2, 3.5.
Correct? Is it 3 point? No, 7 by 2, right? It will be n into n plus 1 divided by 2 into 6. Yeah, it will be 3.5. So what is the meaning of 3.5 here? I said it's a theoretical average, right? So expected value tells us basically we could expect the average of large number of roll to be in the right. So I mean, see, you can't. I suppose I roll a die. You can't say like, yeah, outcome will be 3.5. I will expect 3.5. That is the not meaning here. Meaning of expectation here, it's the average of large number of rolls. Means suppose I roll that die a large number of times. Let's say 50, 100 times and all things. Then average of all the from here, right? Hello,
Sorry, I lost your voice for some time. Can you repeat it, please?
hello.
I lost your voice for some time. You mentioned after 3.5, you mentioned that if there are 500 rolling of dices, then after
Yeah,
that I lost your voice.
yeah. See, expectation of x is nothing but we can say it's a long run average. Okay. What is the meaning of long run average? It's nothing but suppose I roll die a large number of times, right? Okay. And then average of the outcomes of all, I mean, average of all the outcomes will be close to this 3.5. That is the meaning of expectation of my random variable. I can expect when I roll a die a lot of times, a large number of times, then average of that outcomes will be close to this 3.5. Means it's a something long run average. It's something weighted average. Here I am see, if you see, weighted has been assigned, right, to each values kind of things. It's not exact mean.
Okay.
Okay. And what about the variance? See, expectation gives me a central idea. Variance gives, okay, tell me, can you tell me what is the variance? Variance, I can write down this x minus mu whole square. Mu is nothing but the mean of my random variable, right? This is something, correct? So here I'm interested to know the spread of my data set from the mean, from the expected value of my random variable. So variance of x, you can apply this formula also. If you will expand this formula, you will get expectation of x square minus expectation of x whole square. So you can remember this formula or this formula. Okay, so far so good.
Yes.
Okay, now next question is expectation of uniform distribution. See, there are two types of uniform distribution: discrete uniform distribution and continuous uniform distribution. So this is the discrete. X is taking some values and probabilities for each values of x is uniform, is same. Okay, so that is the known as something discrete uniform distribution. So it is said that the expectation of discrete this uniform distribution is given to us as 10. So we have to find the value of n. What should be the value of n? Okay. So here you have to apply the expectation concept. Okay. Accordingly, you have to tell me the value of n. So tell me what should be the correct answer.
I think the right answer is 19.
Okay, n should be 19, right?
Yeah.
Okay. Anybody else? You can tell me your approach also, how you are going to proceed for this question.
Okay, so what happens? The expectation here is 1 by n into 1 plus 1 by n into 2 plus 1 by into 3 up to 1 by n into n.
Okay.
So what you do is you take up 1 by n outside. That gives you inside bracket sum of first natural numbers. Okay, so that is
Okay, let me write.
ah,
Yeah, one second. So you are saying 1 by n as a outside. So 1 plus 2 plus
yeah.
this n, right?
And
Okay.
sum of first natural number is n into n plus 1 by 2.
n into n plus 1 by 2, correct.
And
And
that
n will get cancelled out.
cancelled. तो आप उसे 10 के साथ equate कर दीजिए.
Correct, because this is given to us, expected value of that is 10. So it will be n plus 1 equal to 20. So n will be 20 minus 1, which is 90. That's a correct answer. That's a absolutely correct approach. So you got the meaning of expectation, right? So see, here this is okay. Tell me, you got the meaning of first of all, discrete uniform distribution means x is taking the values and probabilities for each values is equally likely. You can take an example of rolling a die. Suppose I roll a die, I will get value 1, 2, 3, 4, 5, 6, right? What will the probability for each value? It will be 1 by 6, 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 and 1 by 6. Correct?
Yes.
So what is this? This is the nothing but the example of discrete uniform distribution. Correct?
Yes.
Yeah. Here 3.5 is given. We have to find 6.
3.5 is given.
Last time we did that, we computed the E of
No,
x.
I just gave the idea to you. Okay,
No,
you can
I'm
you
just
can
telling you.
Yeah. Correct.
okay,
Correct.
correct.
Rajesh,
Okay,
you're
okay.
right. You're
Suppose
right.
this is n. Okay, I'm
Yeah.
saying this is again n, 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 and n. Okay, I'm saying expected value of this x is given to us 3.5. Tell me value of n. So what it will be? Again, I will get n into n plus 1 divided by 2 into n as 3.5. Correct? N will get cancelled out. So n plus 1 will be 7, and I will get as 6.
Correct.
Correct?
Yes.
Got
Yes.
it?
Yeah.
Yeah. Next is something properties of the expectation and all things. So tell me what should be the correct option?
Prashant, just give us 2 minutes. We'll solve this.
Yeah, please. Yes. Here you have to just think it's nothing but properties of expectation, right?
Prashant, in the second case, it's the whole square is for E of function of x or only for the function of x?
No, it's only for function of x.
Oh, because there's two brackets. Okay.
Yeah.
Okay, got it.
ABD actually.
Which one?
A, B,
A,
D,
B, and
D.
D.
Yeah, D. Correct. A, B, and D. Correct.
Okay.
Huh.
So in the case of expectation, I think that is the correct options. Let me see. Yeah. So in the case of expectation, I can write down these things, right? So expectation of ax plus b is same as the a times of expectation of x plus b, and expectation of ax plus b square. So it will be expectation of ax plus b whole square. So expectation of it will be a square x square plus b square plus 2 times a b x, right? Okay, according to the expansion of a plus b square. When expectation will go inside the bracket, it will be a times a square expectation of x square plus b square, because expectation of a constant is same as that value, plus 2ab expectation of x. So this is the correct option. This is not the correct option, because when you will expand this, you should get minus 2ab times. So fourth option is correct. Okay, suppose in case of I'm saying see, okay, expectation of ax plus b is nothing but a times of expectation of x plus b, correct? What about variance of ax plus b? Sorry,
It will be e of x square minus e of x whole square.
It will be
E
a
of
square variance of x.
correct. It will be a square variance of x. See, what is the variance of a constant value?
Zero.
Why? Because variance of a random variable, what it tells us, expectation of x minus mu whole square, right?
Yeah,
Now,
correct.
I'm saying variance of a constant, nothing but expectation of a minus a whole square.
Correct.
A minus a is 0, so variance of a constant is 0. Now, so variance of ax plus b, it will be variance of ax plus variance of b, it will be 0, and variance of ax will be a square times variance of x. Okay, so this whole things will be equal to a square times variance of x. Why? Because see, I'm saying variance of ax. So if you will put ax, so it will be expectation of ax minus a mu whole square, right? So a I will take as a common, so it will be a square expectation of x minus mu whole square. So this is nothing but again variance of x. So a square times variance of x. Okay, clear?
Yes.
Yeah. Now next question is based on the property of variance. You can expect. So it's saying variance of number of tickets sold in a day in an opera theater is 25. If for each ticket sold the profit obtained is 25 rupees, then what is the variance of the profit obtained in a day in rupees square? Okay, so okay, how will you approach for this one?
the cost is fixed, so let's assume it's b.
Okay,
So it will be like currently we have variance is 25, and now we want variance of x minus
profits.
a. Yeah. I mean to say the cost is fixed for each day.
Okay.
The 25 rupees is fixed.
Mm-hmm.
So we want x minus 25.
X minus 25. And
Oh,
what is
the
your
variance
x?
itself is subtracted, sir.
Okay. Can you tell me what is the given us variance is variance of number of tickets sold in a day in Opera Theatre is 25, right? Suppose my random variable x is number of tickets sold in a day in an opera theater, correct? I'm saying my random variable x is number of tickets sold in opera theater, and it is given to us variance of x is 25, correct?
Yes.
Now, what is the next? If for each ticket sold, the profit obtained is 25, x is represent the number of tickets sold, okay? For each ticket, for the one ticket, profit is 25 rupees.
Oh, multiply 25x.
Okay. What about two tickets? 2 times 25 rupees will be profit. For three tickets, it will be 75. That means 3 into 75. Suppose X number of tickets had been sold, so it will be 25 times of X total profit. So
Yes.
we have to find out the variance of 25 times X, which is will be 25 square into variance of X. So 25 square is nothing but 625 into variance of X is 25. You will multiply this. I think you will get this.
25 cube.
Okay.
Okay.
Is this clear how you can apply this, right?
Yeah. So when you multiply with the mean, it is just taken out. But when you multiply with variance, it's squared and taken out.
Yeah, I can see you can verify from the formula as well. Okay. Now, this is the question again based on the properties of this. So, suppose I have given three random variables x, y, and z. I'm saying y is equal to 2x and x and z are independent. So, variance of x is 2, variance of z is 7. So, tell me value of the standard deviation of x plus y plus z. Okay. So, please try this one. This is the interesting one. I think 2 to 3 minutes you can try. And tell me the what should be the answer.
Is it square root of 13?
Okay, you are saying square root of 13. Okay. Anybody else?
Just I didn't square it. Sorry.
I'll just give us one more minute. One more minute.
Okay, okay. Fine, fine, fine.
Root 41.
Okay, I got another answer, root 41. Okay. Okay, we'll discuss.
Square root of 23.
Square root of 23.
Square
Okay.
root of 70.
70.
Yeah. Change my
Okay.
answer from
Anybody
13 to
else?
17.
Okay, 17, right. Okay. Anybody else? If you're trying, so I can wait, otherwise we'll discuss. Okay. You're not responding, so I'm assuming you are not trying. So see, I think you have done standard deviation of x plus y plus z. Let's compute the variance of x. You know, variance of x is sorry, standard deviation of x is nothing but the square root of x. Okay, so I'm going to compute variance. After that, I will square root of the values because I know the variance, right? So I think, okay, who got square root of 17? How did you approach?
So what I did was standard deviation of sum of variables. I assumed that to be individual sums.
Okay, so you did variance of x plus variance of y plus variance of z. So you did 2 plus variance of z is 7, it's 9, and variance of y is, I think you had done 4
Y-
into 2.
4 into 2, yes, 8.
Okay. 7
Because
plus
2 is
8 plus.
squared, so when it comes out, it's 2 square into variance of x. So it's
Okay.
4 into variance of x, which is 8.
No, okay, who got 20 square root of 23?
Ranjani, hi, me.
Okay, how did you complete?
Okay, see, the thing is, the first thing is variances can only be added if the variables are independent.
Correct,
Sir?
correct.
So the thing
That
is,
is a funda.
so what I did is now standard deviation is square root of variance, but that
Mhm.
cannot be done unless you're expressing x, y, and z in terms of x and z. Okay.
Correct.
So then what I did is I said square root of variance of x plus 2x plus z.
Variance of x plus 2x
X
plus
plus z.
z.
Then,
So far, so good. Correct.
then square root of variance of 3x plus variance of z.
So it will be 9
times
times.
variance of x plus variance of z by square root of that, because we need standard deviation.
Okay, so it will be 25, right?
25. Oh yeah, yeah, 25.
Okay.
So it should be 5. Yeah,
Okay.
yeah.
So standard deviation of x plus y plus z is nothing but square root of variance of x plus y z. That means square root of 25, which is nothing but the 5. So 5 is the correct answer. So I think everyone got the point. I can add the random variables only when my random variables are independent.
Yes.
Okay.
Yes.
So here I do not have information about y, right? As I can say, I have information only about x and z are independent. Okay, so I can transform y in terms of z, sorry, x, then I can do y. Okay, suppose I'm saying variance of x plus y, I can write variance of x plus variance of y only when my x and y are independent, because when it's not independent, then there is a term will come 2 times of covariance of xy, and we will discuss in the stage 2 course basically. But thing is that if x and y are not independent, that means those are related. There is some relationship between x and y. Then it's come. But I'm saying x and y are independent, then it becomes 0. So variance of x plus y will be variance of x plus variance of y. So this formula came from this concept. Okay, forget about this. Just remember, if my variables are independent, then I can write down the separate. But in the expectation, suppose I'm saying expectation of x plus y, it doesn't matter whether x and y are independent or not. It will always be equal to expectation of x plus expectation of y. Okay. Okay. So yeah. So in week 10, I think you know what about Bernoulli and all things? Bernoulli random variables.
Can you revise the expectation and variance formulas for the distributions?
For Bernoulli?
Bernoulli, binomial, exponential, hypergeometric.
Okay, Poisson is also there, right?
Poisson is not, I don't think it's there, but I don't think so.
Okay, in week 10, hypergeometric is there.
The only expectation for hypergeometric derivation is
Only
there.
expectation of,
Nm upon
okay,
capital M. N.
that's all right.
That's it.
No separate about hypergeometric and Poisson, right?
No. Poison I don't think
Okay,
is there,
okay.
no.
Okay, nice. No issues. Okay, so I will come to this point. So
I
what
think,
about the Bernoulli?
sorry to disturb, I saw the syllabus. 11th
Mhm.
point says Poisson distribution also at the end.
I mean, you have the lecture video of Poisson distribution, right? That's what I'm asking.
No, I was talking about the syllabus which was given to us for the exam. It says Poisson.
Mhm.
It
Oh, is
has
it?
Poisson
Okay.
distribution.
Okay.
11th point says so.
Okay, we'll cover those also, no issues.
Thank you.
Not that much complicated. So Bernoulli random variable is nothing but, okay, it's something I have suppose this is nothing but it takes two values, right? Either 1 or either 0. What is meaning of 1 or 0? Means suppose I'm going to do a experiment and outcome of that experiment will be either in success or failure, right? Success or failure means suppose I'm tossing a coin, okay? So suppose I'm interested in head. So if head is come, then I will say it is my success. If it tail, I will say it's a failure. So I can say head is 1. I mean, I'm going to denote as 1 and 0. Okay, if you are doing any experiment and there is only two possible outcomes, that will known as the Bernoulli trial or Bernoulli experiment. Okay, so Bernoulli random variable is taking value only two values 1 and 0. Okay, so probabilities for 1 is P, and what about probabilities for 0?
1 minus P.
1 minus
1 minus P, because I know this is the PMF, so total should be 1, correct? So it will be 1 minus P. If you add P plus 1 minus P, you will get 1. So what is the expectation of X? 1 into P plus 0 into 1 minus P, I will get P, correct? And what about variance of X? See, variance of X is nothing but expectation of X square minus expectation of X whole square, correct? So expectation of X square is what? How will you compute expectation of X square? I will do 1 square into P plus 0 square into 1 minus P, correct? See, expectation of X nothing but summation of X into Px, right? So expectation of X square means summation of square of the values into probabilities. Okay, so it will be 1 square into P plus 0 square into 1 minus P. I will get P again, correct? Are you getting my point here?
Yes, yes.
Okay, so expectation of X square is P minus expectation of X is P, so it will be P square. P I will take common, it will be P into 1 minus P. So for Bernoulli it's a P. For and variance of a Bernoulli random variable is 1 P into 1 minus P. It is clear so far?
yes.
Now come to the hypergeometric. Okay, hypergeometric and Poisson is there, right? Both are there.
The syllabus
Okay, I'm
says
asking.
binomial and Poisson random variables only.
Okay.
Page number, I mean, point number 11 in the second page of the syllabus.
Okay, that's okay. What I'm asking, you got the lecture video, correct?
Yes.
Everyone have the lecture video, okay?
Hmm.
Can you tell me how many lecture video are in that week 11? Just quick check.
Sir, in the playlist, it is only till week 10. 120
Playlist.
videos.
You have playlist or you have a lecture video? I mean,
The
playlist of
playlist
all.
of all the videos, it has
Okay.
120 videos, and it goes on till week 10. And after that, we have some continuous random variable
Okay. The
topic.
week 10, what is the last title of the lecture video?
Week 10, last lecture is binomial distribution expectation.
That's all. I mean, I think in that week, 5 lectures is there, right?
Yeah,
5 lecture video is there?
10.5. Yeah,
Okay.
5 lectures.
Okay, got it. That is meaning of 11.5. There is a mistake.
Okay.
Okay, so I think Poison will not for you. Okay, Poison not for you, but yeah, we'll discuss the Poison for a idea. Okay, but Poison is not for you. Okay, now, so okay, let me come to the hypergeometric. Okay, so what hypergeometric says? Okay, suppose I have total, n items, or you say I have total n capital N box. Okay, out of which suppose I'm saying there are two types of balls. Suppose I'm saying small m ball are, let's say, black color, okay, and remaining capital N minus m ball are, let's say, white color. So far it is clear. I have total capital N balls. I am saying out of those capital N balls, small m are black color balls. Remaining capital N minus m will be white color ball. I'm saying I have to choose a sample of small n size from this without replacement. Okay. So what is the meaning of without replacement? Means I draw a ball and I do not put back in the box. Okay. If I draw a ball and I put back in the box, that means I'm doing the with repetition. Correct? So I have to choose a sample of size n without repetition randomly. And I'm going to define my random variable x as, let's say, number of black balls. Correct? So what will be the probability of x equal to I? I means I number of balls. So what will be the I? Suppose I'm going to choose n random balls. Okay. So it can be 0 black balls, 1 black balls, 2 black balls, and all are black balls. Correct. So what is the value of probability of x equal to y? That means what? What will the probability? Anybody? What will the total number of ways in I can choose n balls, small n balls?
Okay, so it's actually okay. Denominator is n, capital N, C, small n.
Correct. Because this is the see what is the probability? Probability tells us total favorable divided by total, right? So total is I can choose small n balls out of capital N balls is NC n ways. Okay.
Yeah.
Now I'm interested in I number of black balls. In how many ways I can choose I black balls? I have m black balls, MCI way.
Yeah,
Correct.
MCI,
But
correct.
but I'm choosing total n balls, right? Small n balls. That means remaining n minus I black ball, remaining n minus I ball will be from
N minus M.
Okay. So that is the meaning of something that is called this such type of scenario is called the known as the hypergeometric distribution. We'll see an example related to this, and there is an expectation of x. So expectation of x is nothing but the small n into small m divided by capital N. So small n is sample size which we are going to choose, and small m is number of the black box means number of the items of one type. Okay. And is the total. Okay, we'll see the example related to this. Okay, now
Just 1
tell
minute.
me
Just 1 minute.
yes.
Expectation of
Mhm.
x is black ball, right? If it's white ball, it will be n into n minus m by. I mean.
Correct. Yeah, that's why I said n balls have two types. M is black balls and white balls. Okay,
Okay.
you can do that. Okay.
Yeah.
No issues. Now it is clear for everyone, so I can proceed. I will move to the further.
Can you
So
explain
far it
one
is
more time how the numerator came in P of x equal
okay.
to I, MCI into capital N minus M combination of N minus.
Okay. Forgot about this. Suppose I have 10 balls. Okay. I'm saying uh, 3 are red. Let's say 3 are black. Okay. Remaining 7 are white. Okay.
Yes.
Suppose I'm saying X is represent the number of black balls. Okay. And I'm saying you have to choose three balls randomly without replacement. Okay. Tell me what is the probability of X equal to 2?
You want two, which colored balls? Black, is it?
Correct.
So
Why? Why black? Because X is number of black balls. So what will the probability of 2 black balls from this box?
Okay, so denominator is 10C2.
Okay, first of all, tell me denominator.
Denominator is 10C2.
2 or
3.
3? because I said I have to choose the
Three,
three
three, three. Oh,
three
okay,
balls
okay.
without
Yeah.
replacement,
Three,
Yes.
okay.
and what is the probability that out of those three balls, two are black?
Okay,
Yes.
Okay,
okay.
so total case will be 10C3,
Correct, correct, correct.
correct?
Yeah.
Now I'm interested in two black balls, so it
Okay.
will be 3C2.
3C2, yeah.
Now, since we are choosing three balls, that means we have chosen the two for black. That means one ball will be white. Correct? It
Yeah,
is clear?
correct.
Correct? It is clear. I think who has asked this one?
Yeah, Rajesh asked. Yes. What
Yeah.
about the? We have white. You have red, black, and white, right?
No, one is black, white, right?
Black and white. Okay, okay. Three black and.
These
Sorry, I wrote the red, but I cut it.
Okay, sorry, I missed it. I understood. Yes.
these
So,
formulas apply only to two categories so far, right?
Correct.
So at this point, we are only dealing with two categories, correct?
Dealing with two category. I have some total number of items, and out of this one, some number of one type, and some are of another type.
Yeah, okay.
So now let me give you a idea of the binomial distribution. Okay, so binomial distribution or binomial random variable is nothing but it comes from the Bernoulli. What is Bernoulli? See, Bernoulli trial, I know, suppose I'm going to do an experiment or I'm doing a trial, outcomes are only two possible outcomes, right? Either a success or failure. So what is the binomial? So binomial is nothing but suppose I'm doing an experiment in till n number, till n times, right? I mean, I'm doing an independent trials, right? Suppose I'm tossing a coin and I'm tossing the coin 5 times. Okay, I'm doing the 5 tries for that. Okay, then it comes in said as the binomial random variable, because suppose I toss a coin, either I will get head or tail, correct? Suppose I toss coin 2 times, I will get head or tail. I toss 3 times, I will get head or tail. 4 times, I will get head or tail. 5 times, I will get head or tail, right? So suppose x is the, and in case of binomial random variable, x represents the total number of success. Total number of successes that occur in an trial. Suppose I toss coin 5 times. I mean, I'm tossing the coin for 5 tries. So x will be the binomial random variable where x represents the total number of successes when I toss the coin till 5 times. So let's define the total number of successes. Means let's say I'm interested in x as the number of head. Okay, so number of head in 5 times when I toss the coin 5 times. So that's come from the binomial random variable. Are you getting the point or not?
Okay.
Okay.
Yeah.
so what is the difference between the previous distribution is the Bernoulli's distribution?
Hypergeometry, right? Okay, I will come to it. See, in the case of binomial, uh, trials are independent. Okay, trials are the independent Bernoulli trials. Okay, what is the meaning of independent Bernoulli trials? Suppose I toss a coin 1 time, right? Then I toss a coin second time. So tossing coin second time is different, or I mean, is dependent on the first time or not? No,
No.
correct. And this is the something independent. And in the case of binomial, probability of the success should be same for each trial. Okay, probabilities of success should be same for each trial. Means suppose probability of success is, I'm saying, for head is 0.5, right? Suppose I toss a coin for first time, so probability of head will be 0.5.
Yes.
Another time, again probability of success will be 0.5.
Yes.
0.5, 0.5, 0.5. So your probability of success will be same for each trial, right? But in the case of this, your probability will get changed because it's a dependent, right? Your probability will get changed for each trial. Suppose you draw a ball, okay, you are drawing 3 balls. Okay, for first first ball, your probability will be different. For second time, probability will be different. For third time, probability will be different. Okay. So in the case of binomial distribution, probability of success should be same and trials should be independent. It should not be dependent on the previous. Okay. So that's why suppose I can write down the x follows binomial n comma p. N is the number of independent trials. P is the probability of success. So PMF for binomial random variable is, suppose I is the number of success. So it will be n choose I, p raised for I, 1 minus p raised for n minus I. So I is taking the value 0. See, I is the x is the number of success. So 0 number of success is you are going to consider head as success. You toss a coin. If possible, you got tail, right? That means 0 number of success. So 1 success, 2 success, and up to n times success. So this is the PMF for the binomial random. So for in general, I can say suppose x1 is the Bernoulli random variable, x2 is the also Bernoulli random variable. So x1 plus x2 plus so on xn makes the binomial random variable with and independent trials and with success probability as p. Okay, you got the idea. We'll do the question. You will, I mean, things will more clear. You got the funda of the binomial things.
Yeah, I understand. Binomial is for independent success or failure, but I'm not
Yes.
able to connect it with Bernoulli.
No. Bernoulli, see, Bernoulli is for a single trial, right?
Okay.
Bernoulli is for a single trial. Suppose I'm saying my x1 is the tossing coin at the first trial, right? You will get head or tail.
Okay.
X2 is the tossing the coin at the second time, right? And third time, x3. When I will do the whole things, when I will going to consider x1 plus x2, x3, it will form the binomial random variable up to 3 times and success probability is half.
Okay.
Okay, it means I'm doing the my trials and independent times, right? And my success probability is same for each trial. Suppose for this trial success probability is half, for this trial success probability is half, for this trial success probability is half.
Okay. If you take a binomial random variable event and you repeat it multiple times, then you have to represent it using binomial.
And yeah, trials should be independent, right? It does not depend on the previous one, and success probability should be same, right? Let me give you an example. You will get more idea.
Okay.
Okay. Suppose in a box I have 4 white and 3 black. Okay. What is the probability for drawing a black ball?
3/7.
What is the probability of drawing a white ball?
4/7.
Correct. How many balls we have now? 4 white and 2 black. If I draw a black ball and I'm saying I'm drawing the ball without replacement, right? Now for this scenario, what is the probability for drawing a black ball?
2/6.
2/6. What is the probability for drawing a white ball?
4/6.
4/6, correct? Now, for this scenario, I suppose you have drawn a white ball, so you have 3 white and 3 black, right? Remaining. Okay. What is the probability you of drawing a black ball?
Half.
3/6.
3/6.
What is the probability of white ball?
Again 3/6.
Again half. Yeah.
So drawing a black ball at the first trial, drawing a black ball at the second trial is same.
The probability is
Your success probability is not same, right?
yes.
So this is not a binomial. Okay. Means your success probability P should be same for each trial. Okay.
If
now,
it were replaced, then it is
correct.
okay.
Correct. That's what I'm trying to say here. Suppose I'm saying I have to draw the ball with replacement. I mean, I draw the ball and then put it back. Okay, then it will be 3/7. Then I put it back again. Again, I have 4 white and 3 ball. Again, I will get the 3/7. Correct?
Yes.
Correct or not?
Yes.
So
Yes.
again, it will be 4/7. Again, it will be same. So here, your success probability will be same for each trial, right? For the first trial, it's same. For the second trial, it's same. So here, trials are also independent because I put it back. Then second trial doesn't not depend on the first one. If it's without replacement, then it will depend. Correct? So then it will be the binomial case. Okay. I mean, are you getting?
Yes. 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 Clear.
Are you getting Funda? Okay. Now, so what is the expectation of x of Bernoulli? It was p, and variance of x, it was p into 1 minus p. Okay. What about, and see, if x is the, I'm saying x is the binomial. Suppose I'm saying x is the binomial, follow with n comma p. So as we know, x1 plus x2 plus xn will form the binomial, right? So my x is this one, right? So expectation of x1 plus x2 plus so on xn will be expectation of x1 plus expectation of x2. So for each Bernoulli random variable, expectation is p. Okay. So p plus so on, it will be p n times, so it will be np. So mean of the expectation value of the binomial random variable is np. Similarly for the variance. So for the variance, as we know, if all the random variables are independent, so I can write down the variance of x1 plus variance of x2. Okay, and we know we are doing in case of binomial, trials should be independent, right? These are the independent trials. So it will be p into 1 minus p from the binomial, Bernoulli, p into 1 minus p plus so on, p into 1 minus p. So since it is n times, so it will be n p into 1 minus p. So this is the expectation value of binomial random variable, and this is the variance of a binomial random. It is clear for everyone?
Yes.
Yes.
What is the PMF for binomial? Since see, we are doing the things, and see from here, suppose this is the P. Okay, success probability is P, failure probability. See, what is the success in which you are interested? Suppose I am interested in black balls. So failure probability is 1 minus P, means 1 minus 3/7 is same as 4/7, right?
Yes. Yes.
If I'm doing the with repetition, then it's a P, again it's a 1 minus P. Okay. So suppose I'm going to do here 2 times. So what is the success probability? P square. Okay. And failure will be 1 minus P square. I forgot about this. I think you are getting confusion. So PMF for the binomial random variable is nothing but n choose I, p raised to power I, 1 minus p raised to power n minus I, and I can take value 0, 1, 2, so on. Okay. This thing is clear for everyone till binomial. Binomial is clear for everyone.
Yeah.
Yeah. Okay.
Yeah. So next question is similar to that. So apply the concept of binomial and hypergeometry. Okay.
Mm.
So tell me which option should be correct? See, hypergeometric and binomial, there is a basic difference. In hypergeometric, we are drawing the things without replacement, due to which trials will dependent. But in case of binomial, trials should be independent and success probability should be same. In case of hypergeometric, success probability is not same, right?
In the given example, it is mixed bag, so it means that the probability remains the same.
Correct. Correct. That means it will form the something binomial, right?
Yes.
Because we have, for each time we have two outcomes only. Either ball will be red, or I mean marble will be red or marble will be yellow, right? I have only two possible outcomes. Correct? So for each trial, you can consider as Bernoulli. Since we are doing how many marbles we have to draw? 10, right? So since we are doing this and 10 times, so it will form the binomial, okay, with 10 comma success probability what it will be u2, okay. Okay, let me do it. So you are trying or should I proceed?
Can you just give us a minute to try?
Okay. Oh, no issues.
One quick question. So, pi 1 by pi 1 plus pi 2 will be the probability for yellow, right?
Pi 1 is the for yellow marble, probabilities for yellow marble, I mean proportion, yeah, that's same. And pi 2 is the probability for red marble.
Thank you.
Prashant, the answer is
Yes.
B.
Yes, correct. Okay, so thing is that Rajनीश, you are trying or should I proceed? Okay, so urn has total 15 marbles. Okay, suppose this is urn. It has total 15 marbles. 6 are red. Okay, and that if 6 are red, that means remaining will be another kind yellow. Correct?
Yes.
Now, question is said 10 marbles is drawn from the urn. In the question, it has mentioned that marble is kept in the urn and remixed before the next draw, right? That means, uh, suppose I see we are doing the drawing the 10 marbles, right? Suppose I draw marbles one time and I put it back and remix, then drawing marble at second time, it will not, it will independent from the first one, right? So what is the probability for, see, pi 1 is the probability for the yellow marble, okay? So what is the probability for the yellow marble from this? It's a simple probability, right? What will the probability for yellow marble?
9 by 15.
9 by 15, 0.6. What is the probability for red marble? It's just 6 by 15, right?
Yes.
0.4. Okay. So success probability is 0.6. Okay. Suppose I'm saying, okay, you can now you will be related to hypergeometry. Suppose I'm saying suppose this statement is not there, right? And I'm saying I have to draw the marbles without replacement. Okay. Then tell me the probability, and suppose x is represents the number of red ball. Okay. I'm saying number of red ball and without replacement. So tell me what is the probability for x equal to 2?
Red ball, is it?
Red ball. X represents the number of red balls Okay, 10 marbles, sorry, red marbles, sorry about that, and 10 marbles we are drawing without replacement.
So denominator will be 15C10.
Okay, first of all, it's satisfying the hypergeometric conditions, right? I have total capital N items out of M are one type means red, remaining are second type, and I'm choosing a sample of size and without replacement randomly. So probability of x equal to 2 means 2 red marbles. So what will the denominator means total cases?
15C10.
15C
10.
10, right? What about numerator? 2 means what? We have to choose
Select
2
two
red
red
marbles.
balls.
Correct. So it will be 6C2
6C2
into
9C
9C8.
8.
Okay, because we have to do in total 10. Now let's make it capital N. So it's a small m, so it will be capital M. Suppose it's a small n, so it's same as capital N choose n. Suppose I'm going to choose x equal to I, so it will be MCI into n minus m NC. Okay, suppose I'm saying tell me the expected number of red balls. So what it will be?
It'll be
N into M. Okay, Rajni, go ahead.
no, it's okay.
Yeah.
No, it's fine.
Yeah, it's okay. It's okay. Anyone.
N into M upon N. So it will
Capital N,
be
right? What is a small n? Small n means
small
sample
n.
size
10
10
into
into
2.
2. Sure.
No, 6.
6. Okay.
6
Divide by
upon 15.
correct. Now suppose I'm saying x is the number of yellow balls. So expectation of x will be 10
10 into 9 upon 15.
9 by 50. You got the concept?
Yes, sir.
Okay. Now, okay, so this 11th question is based on the previous one. It is asking about you have to find the standard deviation of number of yellow balls drawn. So for the standard deviation computing, variance is good way to compute because variance standard deviation nothing but the positive square root of the variance. So tell me what will the variance of number of yellow balls? See number of yellow balls. Okay, so that means x is going to consider as number of yellow balls for this question. Tell me what is the okay, whether it is see this is the binomial or hypergeometric?
Binomial.
Binomial. Okay, what is the variance of binomial? N p into 1 minus p.
Yes.
So p is the success probability. So here I'm interested in the number of yellow balls. So I mean success probability for the yellow balls. So probability for the yellow balls is what? Pi 1. That means 0.6.
Yeah, 9 by 15.
Okay. Okay, so n is the we are doing the things till 10 times into p is the 0.6 into 1 minus p will be 1 minus p will be I mean 1 minus 0.6 it will be 0.4 and the standard deviation of number of yellow balls drawn it will be square root of 10 into 0.6 into it is clear for everyone.
Yes.
Prashant, in this case,
Yes.
I'm just thinking it is a little easy to be confused between hypergeometric and binomial. So I just wanted to understand how you knew that this is a binomial distribution, the second part of the question.
Maybe the replacement.
Yeah, replacement is the thing, right? Hello.
Oh, okay. Got it.
Okay.
Yeah.
Okay, so what is the condition for binomial? Success probability p should be same, right? For each trial.
Yeah.
Correct.
Hmm.
Right now what I'm saying, okay, it's a 15 marbles, okay, and trials should be independent, correct?
Yes.
Now in this question it is saying marble is kept in the urn and removed before the next draw. correct? So in the urn, I have total 15. Out of 6 are red, 9 are yellow. And I'm saying I have to do the things. I mean, I have to draw the 10 marbles with replacement, right? Suppose I draw a marble. Okay, for first trial, I draw a marble. What is the probability for, okay, yellow marble? Sorry, red marble. Let's proceed with the red marble. It will be 6 by 15.
Yes.
Okay. At the second trial, I'm saying uh, I'm mixed up the things, right? I mean,
Yes, yes, correct. Yeah.
I'm going to put back. So what is the probability for red marble again?
9 by 15.
Red marble.
Uh, red is again 6 by 15 only.
Again 6 by 15, right?
Yeah, correct.
Sir, probability of success. Okay, let's go to this diagram. Okay, let's understand again. Suppose I have 4 white and 3 black. Okay, what is the probability for drawing a black ball? 3 by 7.
Yeah.
Be careful, I'm saying with replacement. Okay, and what is the probability for drawing a white ball? 4 by 7.
4 by 7.
Okay,
Yeah.
so now I will have 4 white and 2 black, or 3 black again, because I'm saying with replacement. I draw and then put it back. Okay,
Correct.
from where, what is the probability of drawing a black ball? Again 3 by 7.
Correct.
White ball 4 by 7.
Mm.
Since I'm doing the with replacement, again it will be same. So again for drawing black ball, I have 3 by 7. For white ball, again I have 4 by 7.
Correct.
Correct? Now, suppose okay, so here success probability is same. P is same for each trial, number of trials.
Correct.
And it's a independent also.
Yes.
Okay. Now I'm saying without replacement. I have to draw the ball without replacement. So for the first time, it's a 3 by 7. You do not have to put back in the urn. Then it will be 2 black ball.
Correct.
What will the probability? It will be 2 by 6 now.
Yeah.
So here probability is going to change.
Got it. Okay.
Correct?
Yeah.
And it's dependent. Okay. Clear?
Yeah. Got it now. Why it is a binomial.
Okay.
Correct.
Yeah.
Got it. Thank you so much, Prashant.
You have to just be clear whether your n number of trials is independent, and success probability for each trial should be the same. Okay. Now come to the next question, 12th one. So you can relate with the, I mean, some of the distribution. I will not going to tell the name of the distribution. So you have to find the expected number of women in the promoted developers. Okay. So tell me which, by reading the question, what it seems to you.
It's Bernoulli distribution.
Okay, why Bernoulli?
Because 5 juniors developers are to be promoted has already been
Okay.
yeah, the main event has already been changed. It's like without replacement something.
So it's without replacement then binomial, or without replacement then hypergeometric?
It's Bernoulli distribution without replacement is Bernoulli distribution. I'm confused now.
Okay, you can rewatch the, see, if it's without replacement, it will not be Bernoulli. See, what is the binomial? If it's without replacement, right? Then your success probability will get changed. But for being a binomial distribution, your success probability should be always same, right?
Yeah.
Okay.
Here
So
the success probability will change.
correct.
Yes.
A question here. Can't a simple probability check be done, because we are taking just 5 people, right, out of the 20, and we are expecting women to be part of it.
Correct.
What is the expected number? Okay.
Okay. what is the expected number. So you can define your random variable x as the number of women promoted to the senior level, right?
And this is the mean E of x is required.
Correct.
Okay. And since it is not replaced,
yeah, how you can replace the numbers, right?
yeah.
Prashant, just give us 1 minute. We'll try. Just
Yeah, please. Yeah. Just try and tell me the what should be the answer. Accordingly, we'll discuss, right? There are a lot of
Is it 3?
okay, someone says 3. Okay, we'll see.
See, the thing is, in a Bernoulli distribution, there are only two possible outcomes for a random variable.
Correct.
Now here what is happening is, since there are 5 junior developers, there are 6 possible outcomes, that is 0 to 5. Okay. For junior developers, so it cannot be a Bernoulli distribution. All right. So it has to be a hypergeometric distribution.
Okay, so simple things. In total, I have 20, right? Total is 20, correct? Out of which 8 are men, right? That means one kind, okay? And 12 are women, right? 8 are men, 12 are women. 5 juniors are developed to be promoted to the senior level, okay? Suppose I'm going to choose a sample of 5 people. So far, so good, okay? It is asking about expected number of women. Suppose, okay, you can relate with the, suppose 12 are red ball, 8 are yellow ball, okay? One kind and different kind. Suppose X is the number of women, okay, promoted to senior level. What is the expected value of X? So what is the M into N divided by N? Whether it is hypergeometric, because see, you can't replace the person, right? Suppose probability of at each trial will get changed. It will depend, right? For the 5 juniors, suppose for the first junior developer, probability will be different. For the second, probability will be different, right? So what is the M? M is what? M is the 12 here, not M is here main. So see, it's you can make it a M. Remaining are N minus N. So what is M is here? 12. Correct?
Yeah.
What is the small n? 5. What is the total? 20. So it's a 60 by 20, which is 3. You got it? There is another approach for this. Okay.
Can I put it like this? So out of 20, 12 are women. So there is
so 12 are women.
Yeah.
And
12 by 20.
8 are men, right?
Yes.
Okay, so there is another approach. Suppose I'm saying X is the number of women, right? Promoted senior level. So what possible values X can take? How many junior developer have to promote it? 5, right?
0.
X can take value 0,
0 to 5.
1, 2, 3, 4, and 5. Okay, it's possible. 0 women are promoted to the senior level, 1 women are promoted to the senior level, and nothing, right?
Yes.
So what will the probability for 0 number of women?
8 by
Denominator
20.
will be 20 C5,
8 by
correct?
20.
8 C5 into 12 C0. No, so not 8 C5. Yeah, 8 C5 it will be, right? See, we are choosing total 5, right? And 0 number of women, that means all should be men. 12 C0. This will be the probability or not for 0.
Yes.
Are you getting this point? Are you getting or not? Right?
Yes. Yes.
Okay. So what about 1 women? Again 20 C5 will be denominator. 1 women means 12 C1. Remaining 4 will be men, then 8 C4. Correct?
Correct.
So similarly for the 2, 3, 4 and 5. So here this is not a form of hypergeometry. Okay. So similarly you can compute the expectation from here also. I mean you will do 0 into this probability plus 1 into this probability plus 2 into corresponding the probabilities plus 3 into probabilities plus 4 into probabilities plus 5 into probabilities, you will get the same answer because expectation of x is nothing but the summation of x into dx. Okay, you got the concept?
So the answer is 3, correct?
Yeah, answer is 3.
Okay, got it, got it, got it.
Well, and another approach is like suppose I'm going to define my xi. Okay, be clear with here. You can apply the concept of properties of expectation. Okay, suppose I'm saying xi is going to denote is the okay. Let's say xi is the random variable. Okay, which okay which will be equal. I mean which will take value 1 if women is selected, and it will take value 0 if main is selected. I can say or not? I'm saying my xi is a random variable which will take value
Okay.
1
Uh,
when women is selected, okay,
uh,
and 0 when main is selected. I can say or not?
yes, yes,
Correct?
Yeah.
I can say.
correct, yeah.
What will the probability when xi will take value 1?
0.6.
It's no 0.6.
1
How
by 2.
many? 20 and 12. No, no, not 1 by 2.
Oh,
It's
sorry.
about 20 and 12 are women and
12 by
8
2.
are men. Okay. So when I'm saying women is selected, what will the probability? 12 by 20.
Yeah.
0.6.
What will and for when main is selected, 8 by 20.
Yes.
So far so good.
Yeah.
Now this is for the ith person, right? Ith person. I'm here. I will take value 1 to 5, right? Be clear. I mean, be try to focus. I'm saying total 5 juniors are promoted. I'm saying for the first person, if it's male, probability is 12 by 20. For the second, if it's sorry, if it's women, 12 by 20. If it's male, it will be 8 by 20. Okay, it is
Right.
clear,
Yes.
right? So what is the expectation of ith person?
I
1 into 12 by 20
yeah
plus
I
0 into 8 by 20. It's a 12 by 20. Okay, this is for the ith person. I have to consider the for 5 juniors, so that means 1 plus 2 plus 3 plus 4 plus 5. I can write or not?
yes.
Okay, so what it will all these things, 12 by 20 plus 12 by 20 plus 12 by 20 up to 5 times. So 12 into 5 by 20, which is again 60 by 20, which is same as the 3. This is same as the your m into n by capital N. It is clear. You can proceed with any of the these three.
Okay, okay. Very nice.
Is it clear for everyone?
Correct. So you're saying the same problem can be interpreted in 3 different distributions, right?
Correct.
Correct,
Correct.
correct, correct. Okay, okay. Great, great, great.
Okay. You
Oh,
can see.
thanks.
I suppose from here. Suppose I don't suppose you for expectation formula of hypergeometry. Okay, this is the 5. It's the long one. Okay, suppose there is question. There is another. Let's say there is question of 5 balls in total. Out of us 3 are red, or let's say 2 are black. Okay, and I have to draw 2 balls at random without replacement. Okay, now let's verify that things. After that, we'll proceed the further. Okay, I'm saying 2 balls we have to choose without replacement. Okay, and x represent the number of black balls. Okay, so what will be the expectation of x? Just by the direct formula, x is number of black balls. This is the total capital N will be correct, and this is the one kind. and this is the n minus n.
Yeah.
So far, so good.
Yes.
This is the small n, right?
Yeah.
So what is the expectation of x? 2 into 2 divided by 5.
Correct. Yeah.
It is 4 by 5. Okay. Let's verify. Suppose x is the number of red black balls. So x can take either value 0 or 1 or 2. Correct? Why till 2? Because I am choosing 2 balls, right? It's possible 0 number of black balls, 1 black balls, 2 black balls. Okay. What will be the probabilities for when 0 black ball is there? Will be 5C2, right? And 0 black ball means all are red. Correct?
Yes.
Okay. What about 1 black ball? Total I'm choosing 2 black balls. 1 black ball means 2C1 into, that means remaining 1 will be from red. Correct? What about 2? It's a 5C2. 2 means all are black balls. Okay. So what is this? 3C2 means, I think 3 factorial, 2 factorial, 2 factorial. So 3 into 2, 2 will get cancel out. 3C2 will be 3 factorial, 2 into 1 factorial. Okay, it's a 3, right? And 5C2 will be 10, and it will be 6 by 10, and it will be 1 by 10. Okay. Now let's verify. So expectation of x is what? Summation of x into px, right?
Yes.
So 0 into 3 by 10 plus 1 into 6 by 10 plus 2 into 1 by 10, right? This. Okay. So 6 by 10 plus 2 by 10 is nothing but 8 by 10, which is same as 4 by 5.
Oh, yes.
Which is same as 4 by 5.
Yes.
So you can proceed with anyone. No issues.
Wow.
It's clear?
Yes, yes, very clear.
Okay, so Poisson distribution is not there, but I can give you a idea. Okay, so Poisson distribution is nothing but uh, okay. So Poisson distribution is see, binomial for there are cases like, and should be an independent trial success of probability should be same. For the Poisson distribution, I'm just going to give an idea. You can watch from it. So because it's not for you, so okay. So Poisson distribution is when I'm interested in number of occurrences of events, okay, in a interval of time. Okay, interval of time is, suppose I'm interested in number of deaths or number of accidents. You can say in a month kind of things, right? Or number of car passing in another crossing, right? Like that. So in that situation, Poisson distribution comes into the picture. And for Poisson distribution, there is a PMF. So PMF is called probability x equal to lambda. Okay, sorry, x equal to x means x number of occurrences. PMF for this is nothing but e raised to power minus lambda, lambda raised to power x upon x factorial. X is nothing but the 0, 1, 2, and so on, because x represents the number of occurrences of events in a given interval of time or in a length of space. Lambda is a parameter of that Poisson distribution. And by default, or you can calculate, expectation of x is lambda, and variance of x is also lambda in case of Poisson distribution. This is something you can, if you want, so you can explore. Okay, this is something Poisson distribution. So I'm going to give you a idea. Like a car firm has 2 cars which hires out day by day. The number of demands for a car on each day is distributed as Poisson distribution with mean 1.5. As I told you, in case of Poisson, expectation is same as lambda, right? So it says mean is 1.5 is given to us, means lambda is given to me. Okay, and says calculate the proportion of day on which neither car is used. So neither car is used means what?
Zero.
So neither car is used means x is will take value
Zero.
0. As I say, if x equal to x means e raised to power minus lambda, lambda raised to power x upon x factorial. So it will be e raised to power minus lambda, as lambda is 1.5, so it will be 1.5. 1.5 raised to power 0 divided by 0 factorial, it will be e raised to power minus 1.5. You will get the value of e, I think 2.718 something. You can calculate it, you will get this. This is something you, if you want, so you can explore. Okay. Now come to the continuous random variable. Okay. You know, okay, as we have discussed, continuous random variable, right? We cannot count. We have to measure the continuous data set. Okay, these things you are familiar, right?
Yeah.
Now, thing is that since we cannot take, we cannot count the thing, right? So we can measure, right? And we can measure, and thing is that continuous random variable can take any value within a given interval, right? So in case of continuous random variable, we are going to consider interval. What will be the values? What will be the probabilities within the interval? Because we cannot take, see, in the case of discrete, we can consider the distinct value, yeah, 1, 2, 3, 4, and all things, right? Because we can count. But in case of continuous, we cannot take the distinct value, right? We have to consider a range. Okay. So for such scenario, area, okay, suppose I'm interested in probability of A is less or equal to X less or equal to B. Okay. Since this is the continuous, okay, suppose this is the X, this is the f of X. Okay. So in case of discrete, we are representing the Px as the probabilities. Okay. Suppose this is the your given things, and I'm saying A is this and B is this. Okay. And I want to find the probability of X is will lie between A to B. Then how will you find?
You'll have to use a definite integral which is bounded from
Correct.
A to B.
Correct. Because to find the region, that means we have to find out this region, right? We have to find out the this region, because okay. So we have to integrate A to B fx dx. Fx means this PDF. Okay. That means the, okay. So suppose X is taking value, some range it will given to you, and fx is the known as the PDF of your uniform distribution. According to the conditions, PDF will get changed. Okay, I mean, are you getting the meaning of things?
Yes.
Yeah. So what I was saying, so okay, are you getting this point or not? Because since we cannot count the things, we have to measure a area. We have to find out the area. So in case of continuous, we have to integrate the region. Are you getting this point or need difficulty in this?
Yes,
What I'm
sir.
saying? Okay. So thing is that, see, as we in the case of discrete, we know probabilities should be greater or equal to 0, and sum of all the probabilities should be equal to 1. Correct? So in case of continuous, this fx is also a probability, so it should be greater or equal to 0. Since we cannot count, we cannot, okay, distinguish between, so we have to integrate the fx, and integration of fx throughout the range of x should be equal to 1. That is the two criteria for being a PDF, probability density function. Means area under the whole curve, x is going to take should be equal to 1. Okay. Are you getting this point?
Yes.
Okay. Can you tell me probability at a single point in case of continuous?
It is equal to 0.
Correct. Because range, okay, region for that point will not, we cannot compute, right? And probability at a singleton point will be 0. Okay, you can identify the, I mean, you can derive, okay, suppose for the probability A is less or equal to X less or equal to B, okay, it was A to B fx dx, correct? Now, suppose I'm saying probability x equal to A, that means A to A fx dx. When you will integrate, you will get 0, A minus A, okay? Is everyone getting this point, or any difficulty for this?
Yes, sir.
It's clear. So thing is that in case of continuous, suppose I'm going to write A is less or equal to B. This is same as A is less or equal to X less than B. This is same as A is less than X less than B. This will same as A is less than X less than B. But in case of discrete, this is the different, this is the different, this is the different, and this is the, okay. In case of continuous, because probability at a single point will always be 0. Okay, probability at a singleton is a 0 in case of continuous. So for this I have to integrate, I have to find the area under the curve from A to B for this, A to B for this, A to B for this, A to B. Okay, and this is same as the, see, if I have probability A is less or equal to X less or equal to B, so can I write probability X is less or equal to B minus probability of X is less or equal to A or not?
Yes, yes.
I have A here, I have B here, okay,
Correct. Mhm.
okay. So for find the probability X is less or equal to B, I can subtract probability X is less or equal to B minus X is less or equal to A, correct? So
Yes.
that means, see, you know what was the CDF? Probability less or equal to at a single point, right? Correct? So for this, I can write down the f of B minus, for this I can write down the f of A. I can write,
Yes.
okay. You are getting the point? Now, in case of discrete, expectation of X was summation of X into Px, right? But in case of continuous, it will be integration of X into Fx dx. Okay, so summation will get the replaced by the integration, because we are interested in a interval. For that we have to find the region of that. Okay, it is clear for everyone? I mean, you are getting the concept, or
Yeah.
okay? Yeah, if there is any difficulty, you can discuss the thing. Okay, so let's come at the uniform distribution or continuous uniform distribution. Okay, okay, if any one of you are not aware about the integration, no issues with that. There will not be questions in the exam which include the integration. If you know, that will be, that's better. So thing is that there will be questions, you can directly apply the concept, but yeah, you have to remember some formula then. Okay, so I'm saying a continuous random variable X has a uniform distribution. I can denote X follow uniform A comma B. So thing is that suppose this is something X and this is something PDF, I mean Y of X. So uniform means, suppose this is my A, this is my B. Okay, so uniform means, suppose this is the, say this is value K. This is uniform means it's uniformly distributed from A to B. I can say, right? It's uniformly distributed to A to B, right? So far it is good.
Yes.
So what will be the area? If you see it, the dotted line, what is the area for this?
It is the total area should be 1.
Total
K
area
into
should be
P
1.
minus A.
Okay, so area is will be K into 1 upon B minus A. Okay, because it's something okay. and I know if it's PDF, so total area should be no, I think
Should K into
one
B
second.
minus A because
Yeah. It should be K into B minus A, right?
yeah.
K into B minus A should be equal to 1 because K is the height, right? And what is the, I mean, what is the area formula for a rectangle?
Length
Length
into
into
breadth.
breadth. Okay, so length is K, this K, right? And breadth is P minus A. So total area should be 1. So I will say K is nothing but 1 upon B minus A or not?
Yes.
Correct? So that is something this continuous uniform distribution means suppose I'm saying f of x is k and a is lies between a to b. So PDF of uniform distribution is 1 upon b minus a when x is lies between a to b means this is the PDF formula for the uniform distribution. Okay, you can identify, you can find out the from the integration also, like I can find out the a to b fx dx. Okay, so fx is here k is the k dx, so k will be outside, it will be a to b 1 dx. You will get k into x, okay, a to b, since total area should be 1, so it will be k into b minus a equal to 1. You will get k as 1 upon b minus a. So this is nothing but the PDF of the uniform distribution. X is going to take the values from in the interval a to b, and PDF is the f of x is 1 upon b minus. It is clear?
One quick question.
Yes,
So
yes,
it
please.
means if A and B are further apart, K value will be lesser, right?
A and b are,
Further apart. If the variable is in a
yes.
very large, if
So
it's
this
in a
is the
very
PDF. Yes, please go ahead.
if A is 1 and B is say 100,
Mm-hmm.
then it will be 1 by 99.
1 by
And
99. That's all.
yeah, and if it's like 500, it will be 1 by 499. So
Correct.
further
Correct.
apart, the constant value will be lesser. Okay.
Correct. Correct. That's why I said uniformly distributed, right? It will be
Mm.
uniform from your initial point to end point, right? It should be
Mm.
uniform, right? Since it's continuous, so we cannot distinguish, right? We cannot take the distinct value. Okay. So what will be the f of x? CDF. I can write down the probability of x is less than equal to x, correct? For the CDF,
Yeah.
right? So what is the CDF formula? Anyone have remember?
This is for you're asking for a uniform distribution?
Yeah, uniform.
Okay, for it is 0 for x less than a.
Yes,
0 for
0
x.
for x greater than b and 1 by b minus a if it is between a and b.
It is 0 for x less than a. It is
Okay.
it's
Okay, just
actually
yeah.
x
I
minus.
okay. I am getting your point. Yes. Okay, you are saying since it is taking value x, you are saying x is less than a, it will be 0, right?
Mm-hmm.
If x will lies between a to b, it will be x minus a, b minus a, right?
Yes,
And
correct.
if x is greater or equal to b, so
It's
1.
1. 1.
So yeah, I was not there. I was just asking about the CDF formula, which is this one. Okay, means if suppose I'm saying x is follow uniform distribution a to b. Okay, so that means CDF formula for this uniform distribution is nothing but the x minus a divided by b minus a. Small x is this value. See, these things you can compute by the integration formula as well. As my random variable x lower limit, see, my x is lies between a to b, correct? So
Yes.
from here, I have to integrate a to x, right?
Mm-hmm.
Fx dx, correct? A to x, what is the PDF of uniform distribution? 1 upon b minus a dx, right? So 1 upon b minus a will be outside, it will be a to x dx. Okay, so 1 upon b minus a, it will be x a
Minus
to
a.
x. You will get x minus a divided by b minus a, which is the same as this. So you can memorize the formula for your simplicity. So okay, if X is follow uniform A to B, what is the PDF? I'm going to revise the quick formula. 1 upon B minus A, right? And what is the CDF? X minus A divided by B minus A, right? What is the expected value of X? Anyone? Anyone have remembered?
1 by, it should be K, that is 1 by B minus A, right?
It's B
No, no,
square minus
expected.
A square by 12.
Nahin.
Or is B?
Expected value of X is nothing but A plus B by 2 in case of uniform. You can define find out
Yes.
from the, okay, from here also. If you will integrate, it will be X into 1 upon B minus A dx. Okay, 1 upon B minus A will be outside. X, see, we have to integrate from A to B, right?
Correct, correct, correct. Correct.
So x you will integrate, you will get x square by 2 something A to B, right? Then you will get B plus A, sorry, A plus B by 2 in case of uniform. And variance of X for the uniform random variable is B minus A whole square by 12.
12,
Okay, I
correct.
mean you
Yes.
can find out from the integration. I'm not going to that. So this is the 3 to 4 formula, important formula for the uniform. If you remember this formula, you can easily solve the questions. Suppose in the question it is asked about what is the probability X will take at most 3. Okay, so at most 3 means it cannot exceed 3. That means you have to apply direct CDF formula, right? Are you getting
Okay,
my point?
because P is less than equal to 3,
P
then you
is
have to
less than
put
equal to 3. Then you do not need to do the integration. You, if you remember the sorry, CDF formula, you will directly apply. You will get the answer. Okay. Okay, so there is another distribution called exponential distribution. So suppose I'm saying X is follow exponential distribution with parameter lambda. So PDF for this is nothing but the lambda into e raised to power minus lambda x, and my x can take value greater or equal to 0, and it will take value 0 otherwise to this range. Okay, so this is the PDF for the exponential distribution. Okay, so what is the CDF for exponential distribution? That means probability X is less or equal to small x. Okay, see, a capital X represent a random variable, and a small x is going to represent a value which your random variable will take. Okay, so what is this? I can integrate 0 to x, correct? Because x is 0, right? And what is the, this is the fx dx. Okay, so 0 to x, I have to lambda e raised to power minus lambda x dx, correct? Lambda will be outside to the integration. It will be 0 to x e raised to power minus lambda x dx. Okay, lambda into e raised to power minus lambda x, it will be minus time minus lambda. 0 to x, lambda will get cancelled out. You will get minus e raised to power minus lambda x minus e raised to power 0. It will be minus e raised to power minus lambda x minus 1. That means at the end you will get 1 minus e raised to power minus lambda x, right? Are you getting this point? Is it okay for everyone or any doubt in this? Hello? Hello? This thing is clear?
Yeah, got the formula, yes.
Yeah.
Yeah.
So this is the CDF formula for the exponential distribution. Suppose I'm saying, tell me the probability of at least 3. Means it can take value 3 or more than 3, right?
Yeah.
Okay, I mean greater or equal to 3. Suppose in any situation you are going to find at least. Okay, so this is the meaning of at least x. Okay, so this is thing, so I can write down 1 minus probability x is less than x or not. Probability x is greater or equal to x, I can write down 1 minus probability x is less than x. This thing is clear or not? See, probability
Yeah,
of A is same as 1 minus probability of A complement.
correct.
Correct? So this is 1 minus, and since it is the continuous, so probability of x is less than x means same as probability x is less or equal to x. Right? So what is the CDF formula for f of x? 1 minus e raised to power minus lambda x in case of exponential distribution. So 1 will get cancel out, you will get e raised to power minus lambda x. So you can also write down this formula. So these are the two important formula for this. You will get, I mean, you can solve the questions very quickly. Okay. Suppose any question it's asking about, tell me the probability at least 3, at least 4, you will get applied. And what is the expected value of exponential distribution? Anybody? By the concept, I have to
1 by
do like
lambda.
this, right? I have to do like this. If you solve by this, you will get 1 by lambda. And
Lambda
variance of x in case of exponential distribution is 1 by lambda
square.
square. Okay, let's do a quick revision for these two formula. These are very important formula for to you. Suppose x is follow uniform distribution with a comma b. What is the PDF?
PDF.
1
Okay.
upon b minus a.
Yeah.
A will lie between a to b. Okay, you can write it a is less than x less than b. Anything will be fine because since it is a continuous. What is the CDF formula?
X minus a upon b minus a.
X minus a upon b minus a. What is the expected value?
Expected value is
A
b
plus b
plus
by
a.
2. What is the variance?
B minus a the whole square by 12.
Correct. Now,
Yeah.
suppose x is follow exponential distribution with parameter lambda. What is the PDF? Lambda into e raised to power minus lambda x.
Yeah.
My
Correct.
x will take any value greater or equal to 0.
Correct.
What is the CDF?
1 minus e raised to
1
minus
minus.
lambda. E raised to
Correct.
minus lambda x.
What is the probability x is greater than x? E raised to power minus.
Minus x. Subtract from
What
1.
is subtract from 1? What is the expected value of x? 1 by.
1 by lambda.
What is the variance of x?
1 by lambda square.
Now, come to the question. Now, you will be able to relate. So, lifetime, okay, exponential distribution is basically used in the situation when, I'm interested to know distribution of amount of time until some specific event is going to occur, right? So here amount of time. So lifetime of a light bulb is exponentially distributed with a mean life of 18 months. There is a 60% chance that a light bulb will last at most t months. So it is asking about value of t. So first of all, tell me what the things is given in the questions. Lambda is given to, okay, it's saying mean life of 18 months. Okay, so suppose x is follow exponential distribution with lambda. So what is the expectation of x in case of exponential distribution? It's 1 by lambda.
Yes.
So if you see mean life is given to you, means 1 by lambda is given to us as 18.
Yes.
So lambda will be 1 by 18.
Yes.
Okay. Now, next statement is there is 60% chance that light bulb will last at most t months. Means probability of light bulb will last at most t months. Chance is 60%. Correct. This thing is given to us.
0.6.
So far it is clear.
Yes.
It is asked about what is the t. What is this? This is looks like something CDF for the exponential distribution. What is the CDF tells us? Probability x is less or equal to x, right?
Yes.
And so you are okay with the meaning of at most t, at least t. Okay, suppose I'm saying at least t, so it will be greater or equal to t, right? At least t means it can take value t and greater than t. At most t means it cannot exceed the t. It can take maximum value as this point, right? So what is the CDF formula for the exponential distribution? It is 1 minus e raised to power minus lambda times x, right?
Yes.
So I can write 1 minus e raised to power minus lambda times, instead of x I have t, right? Which is nothing but 0.6, right? So from here, can I write down the 1 minus 0.6 is equal to e raised power minus lambda times t? E raised power minus lambda times t is same as 0.4. Correct?
Correct, yeah.
Okay. So thing is that from here, okay, I can write down the 1 by e raised power lambda t, e raised power minus lambda times t. I can write down 1 by lambda t, 1 by e raised power lambda t is same as 0.4. I mean, from here it's something mathematical computation. So you got the, I mean, what I'm trying to say here, you got the concept right. Expectation is given to you. So 1 by lambda is given to you, not lambda, right? Sometimes people make mistake, they directly take lambda as 18. No, mean is given to you, means expectation is given to you. So lambda will be 1 by 18. Okay, let's conclude the things. And from here, I can apply the CDF formula. Okay, here I'm trying to say like when you can apply the formula. Okay, you got the main funda, right?
Yes.
Yes.
Yeah. So from here, I have to apply the some mathematical things. So I can write down this 1 by e raised power lambda t, and see, you know 1 by x is same as x raised power minus 1, right? That the same things I have done here. So I can write down 1 upon 0.4 as e raised power lambda t or not. Means this side and 1 by 4 should be left hand side, right? So this is
Yes.
same as 2.5 as e raised power lambda t.
Correct.
If you will take logarithm, so it will be ln 2.5, it will be ln e raised power lambda t. Okay,
Correct.
you know ln of e raised power x same as the x. Okay, so it will be ln e raised power lambda t will be same as the lambda t. So lambda t is the ln 2.5. So here t will be 1 by lambda ln 2.5, and 1 by lambda is given to us as 18. So it will be 18 ln 2.5. So C, option C is the correct. So this is something mathematical, which is the simple. But thing is that I was to try to explain these things, right? Be careful what's given to you, and be careful what is given to you. Like suppose it's given to us at least. Suppose I'm saying probability that light bulb will lost in at least t months is 0.4. That means probability x is greater or equal to t will be 0.4, right?
Okay.
You solve, you will get the same. Now come to the next question. It's something saying traveling duration of the time taken every day by a train is uniformly distributed between 200 and 220 minutes. What is the probability that duration of the time taken is more than 215 minutes, given that on that day more than 210 minutes of the time was taken? So, I mean, here you have to just tell me, I mean, you can take your time, 5 minutes, 6 minutes, and tell me how will you approach.
So this is going to be a conditional probability.
Correct.
Okay.
Correct.
Yeah,
That's
yeah,
nice.
correct. So I'll just continue. I'll just give me a minute. I'll just, yeah.
Okay, okay, sure, sure, sure. No issues. Okay, just do it. I will be back in 2 minutes. Okay, please do it. Hello.
So I think the answer is 1/4.
Okay. It's 220 minutes. Okay, so tell me your approach. We'll proceed and we'll see whether your calculation is correct or not.
Yeah, the A and B
So
values
X
are given.
is follow uniform 200 to 220. Correct?
Yes.
This is
Yes.
given to us, right?
Yes.
Now,
A is 200, B is 220.
220. It is asking about probability that duration of time taken is more than 215 minutes. So what is meaning of that? X is greater than 250.
Yes.
Given that we have to find the probability X is greater than 250, given that on that day more than 210 minutes of the time was taken. More than 210 minutes time was taken. This thing, okay? So
Oh,
these things we
given.
have to find out, right?
Okay. This is probability of A given B is probability of
So what is the probability of A given B? This thing,
Yeah.
right? So from here I can say probability of X is greater than 215, comma means intersection, and X is greater than 210 divide by probability of X is greater than 210, right? Now we have to find the intersection for this and this. Okay, suppose this is 210 and this is 215. Okay, so I'm saying greater than 215 means this black region, and greater than 210 means from this orange region. Okay, so what is the common between these two? This greater than 215 violet region, intersection
Yes.
point
Yeah.
will be this, right?
Correct.
okay.
Okay,
Hmm.
so that means intersection point is probability X is greater than 215 divided by probability of X is greater than 210. So far so good. It is so far it's okay.
Yes.
Okay, now since see this is X greater than 215, but in case of uniform and all things, I know the CDF formula, right? So can I
Yeah.
write this 1 minus probability X is less or equal to 215 or not? Because these things I can compute by the formula directly, right?
Yes.
Okay, and same for the denominator, I can write 1 minus probability X is less or equal to 210.
Yeah.
Correct. Now what is the CDF formula when for the in case of uniform? It's X minus A divided by B minus A.
Yes.
So what will the CDF formula when X is less or equal to 250? Since A is 200 to 220, right? So X is 250 minus A is 200 divided by B minus A means 220 minus 200. So we got 15 divided by 20.
Yes.
Correct. What is probability X is less or equal to 210? 210 minus 200 divided by 220 minus 200.
10/2.
You get 10 by 20. So far it is clear.
Yes.
I
Now
have this value, I have this value, so I can do 1 minus 15 by 20 divided by 1 minus 10 by 20. So what will be the numerator? It will be 20 minus 15, 5 by 20. Whole divided by 20 minus 10, it will be 10 by 20.
1/2.
So 20 will get cancelled, you will get 5 by 10, which is 2, 1 by 2, which is 2 by 2. So
Okay.
it's clear. I mean, you are getting what I'm trying to explain here. If you know the formulas, see, you should know the funda of the formulas, where formulas came and all things. But for now, if you have remembered the formula, then you can easily apply the things and you will get the answer.
Okay.
Okay, it is clear?
Yes.
Clear for
The
everybody?
trick is to identify that area.
Correct. You have to identify area, and suppose I'm saying, okay, suppose I'm saying what is the probability of the duration of time taken is at least 215 minutes. That means I have to find the probability of at least 200 greater or equal to 215 minutes. Forget about this line is not given to you. I'm saying what is the probability that duration of the time taken is at least 215 minutes. So it can take more at least 215 and more than 215, correct?
Yes.
So since I know the CDF, so I can write down the probability of x is less or equal to 215. Since it is a continuous, so equality doesn't matter. So here I can directly apply the CDF formula of the. Okay, suppose I'm saying tell me the probability of it will take at most 215 minutes. That means it cannot exceed 215 minutes. It will take at most maximum, maximum value will be 215. So you have to directly compute that this one. So it will be 215 minus 200 divided by 220. That is the sign.
10 by 20.
Okay, I mean you have to be clear with the statement. That's all.
How you concluded this as a conditional probability? Can you please guide us here?
Okay, so conditional in the question, it directly asks with you, to me. It says what is the probability that duration of the time taken is more than 215 minutes? What is the probability? Okay, let me write down the according to a statement. I'm not writing the any extra thing. So it is asking about what is the probability? What is the probability of what? Duration of the time taken is more than 215 minutes. Suppose duration of the time is represented by x. So x is more than 215 minutes. So far, so good. Correct?
Yes.
Given that, on that day more than 210 minutes. So on that day more than 210 minutes. That's all. And here you have to apply the conditional probability. Okay.
Yeah.
So I think I have covered the concepts up till week 12. Okay. You guys got the mail regarding any live session? I mean, YouTube link of Usama?
Usha ma'am, live link.
Not live, it's a recorded. I mean,
Whatever we have got is is on the website only, that the 120 lectures.
no, not that one. Okay, what was the mail of today's?
It's about hall ticket.
I'm asking in the mail, do you received any revision session of 11 and 12 by Usama something? Any YouTube link?
Let me check.
I think today we have received an email with the latest YouTube link. The session of the live sessions.
Okay. Anybody can confirm?
Today at 4:43 p.m. I have received an email.
Okay.
It's just regarding the information about the
Sessions.
lectures for today, huh?
Okay. Okay, I will check those. Okay, you got the concepts of all the topics, how we can proceed, how can we can understand the meaning of statements.
Yes. Is there some shortcuts you can suggest us? Like when you said given that it's conditional probability, when
So shortcuts, if you are okay, if you are familiar with the area formulas and all things, okay, then you can directly compute the things. Like I'm going to just give you alternate approach for that one, as you said. So since okay, let me erase for a minute. See, shortcut is nothing but you have to, I mean, for the exams, you have to memorize the formulas, right? So for the things, but yeah, if you are familiar with the area principle and all things, okay. So you know what is about the uniform? This is suppose this is 200, okay. This is 220 as we have done. Suppose this is A, this is P. It will take value K and it's uniformly distributed from A to B, right? These things we know, correct? So
Yes.
yeah, okay. So suppose this is uh, my PDF is uniformly goes from 200 to 220. Okay, it is asking about more than 215 minutes and given that more than 210. I can plot a dotted line here. Okay, now so 210. Okay, 210 will be from here in between, and
Yes.
215 will be somewhere else, right?
Yes.
Okay, now if I'm saying probability of x is greater than 215 given that x is greater than 210, so I'm saying it is given that, okay, suppose this green region is given to me, okay.
Mm-hmm.
What is the probability for this green region
Um,
by the area principle?
10
This
into
is
10
this is
into
1
8.
upon b minus a, this is 1 upon 20,
Yes.
right? So this is the height. So for the green region I have 1 by
10,
20 into 10,
10. Yes.
that means half.
Yes.
Okay, but this half is given to me, right? I have to find out the probability when it is greater than 215, right? What about this red region? Again 1 by 20 into 5, which is 1 by 4. Since we have to find out the probability, so my favorable is 1 by 4 and total is 1 by 2, so it will be 1 by 4 into 2 by 1, which is again half, which is with 1.
Okay.
Okay, see what is the conditional probability? Suppose I'm saying I have this Venn diagram, okay. Suppose this is my A, this is my B. Suppose I'm saying probability of A given B. A given B means B means B has been occurred, right? That
Mm.
means I'm saying my this green region has been occurred.
Mm.
Means my new sample space will be this my green region, okay.
Mm.
What is the probability of A when this green region has been occurred? So probability of A means this red region
Yes.
when B has been occurred. So what is the total? What is the probability? Favorable by total, right? So
Mm.
my total is green region, means probability of B. Favorable is this red region,
Mm.
which is A intersection B. So that's the formula came from like this.
Okay.
Okay. So similarly, green region is my total, which is half. Red region is 1 by 4. So 1 by 4 by 1 by 2, again half. Okay.
Yes.
Right. Okay.
So
So I mean, there is
is there
a lot
is
of
there a is there a place where these formulas are tabulated, like what is PDF f of x, e of x, v of x? So it's like easy for us to.
not place you can do I think Wikipedia and all things. But in the lecture video, ma'am has clearly done the things. And if you know the integration, so just integrate. Suppose I'm saying expectation of x, so you have to just integrate integration of x into fx dx. Put the value of PDF, I mean f of x, you will get the expected value.
Yes, yes.
Expected of x square.
That's what I understand. I was asking, like, for the formulas for each of the distributions, is there a
Mhm.
tabular column which says what is the PDF, what is the f of x, what is e of x, what is v of
No, no,
x?
no. I have just written here. You can note down for yourself. You have to write down. Okay,
Okay,
or yeah, you can put it. Accordingly, you can make your notes.
okay.
Okay, so I think all the things has been covered. Is there anything else if you want? Otherwise, we can wind up the session. Hope I was covered all the topics and you got the concept.
Prashant, if it's all right with you, can we add you on LinkedIn?
Sorry.
If it's all right with you, can we add you on LinkedIn?
Yeah, it's okay. A lot of students are there.
Okay, okay. So, how do I? Can you just put your LinkedIn, ID, and I'll add you.
So for now, I have to open in my laptop, I think.
Okay, no problem. Prashant.
Okay, you can.
Tell me. How do I find you?
Your voice is breaking, Ranjini.
I said, how do I find you? How do I find you? Because there are many Prashants. So how do I find
Okay,
you?
it's something written IITM, PhD degree and all things. Project associate for IITs.
Okay, so IIT PhD and
BHD. IITM, this IITM degree, you can put the degree name or project associate, you will get.
Okay. And Prashant, one more thing I wanted to ask is marital status is what kind of variable? Nominal?
Okay, you tell me. What should be?
I think it's nominal.
Yeah, correct. You cannot order, right?
Yeah, I cannot order. Then okay, and battery life is continuous, right?
Battery life is continuous.
Okay.
It cannot
But is
take.
it numerical? Is it numerical?
Yeah, but see, what is the categorical and numerical? If I'm able to perform any meaningful mathematical operation, then it will be numerical. Okay. If I'm not able to perform any meaningful mathematical operation, then it will be categorical, whether it is taking the values or not. Okay. Suppose, let me share my screen for a minute. Okay. Suppose I'm saying, okay, suppose I have gender, okay, female. I'm taking just these two, correct, female and male. Suppose I'm going to code female as 1, male as 0. Okay.
Yeah.
So is there any mathematical operation I can perform? I can say 1 plus 0 is same as 1.
No.
That does not mean anything.
Yeah,
Okay.
correct.
So here we cannot perform any meaningful mathematical operation, but it looks like a number. But thing is that you have to think whether it is number is used as for label or is something numerical properties, right?
Okay.
Okay. Suppose I'm saying Aadhaar card number. Okay. So it's categorical or numerical?
It's categorical.
Okay, it's a categorical because suppose I'm saying Aadhaar card number, it looks like a number, but we can't say your Aadhaar card number is greater than my Aadhaar card number, or we can't say Aadhaar number, sum of the your Aadhaar card number and my Aadhaar card number is same as the someone is. But it does not mean mathematical meaning, right? Okay. So if you are able to perform any meaningful mathematical operation, then it will be numerical, otherwise it's categorical. Similarly, phone number. You can't say your phone number is greater than my phone number. That does not make any sense, right?
Correct. Yeah.
Okay.
Correct.
So like that, you have to just think pin code. Suppose jersey number of the players, it looks like 7. Jersey number player for Dhoni is 7, for another player is 12. But you can't say 12 is greater than 7.
Right. Okay. Yeah.
Right?
Yeah.
Got it?
Yeah. Sure. Okay.
Okay, guys. Is there anything else so you can discuss? Otherwise, I hope you got the concepts.
Okay. It's your okay. So it's written project associate at IIT Madras.
Yeah.
Okay, great. I'll add you. Great.
Okay.
Right. Thank you so much, Prashant. We learned a lot, and hopefully we're all able to clear.
Yeah, that's why I was going to say all the very best to all of you.
Thank you so much.
Clear the exam and we'll meet possible.
Yeah, sure. Thank you so
Okay,
much.
and
Thank you so much,
thanks,
Prashant.
guys. I hope your concepts are clear. Okay.
Thank you so
Thanks,
much, Prashant.
guys. All the best.
Bye, everybody.
Thanks.
All the best. Bye.
Bye, everyone. Bye.
Thanks. All the best, everyone.
All the
Yeah,
best. Thank you.
everyone.
Bye.